Good morning, everyone. We had a good session yesterday. So today we are going to focus on RDA fundamentals and data automation. And so obviously, part of the introduction of these fundamentals, we are going to go through slides first, so that we can explain about the concepts, about what RDA is and what the bots are, pipelines, what are the different artifacts within this subject, followed by hands-on labs. We'll try to complete the slides as early as possible, and feel free to ask questions as yesterday. Thanks for being very interactive yesterday. So let's maintain the same, and then we'll have a labs. And the way we did yesterday, we'll follow the similar approach, and we can go through lab exercise. Okay, with that. Okay, today's topics, we're going to talk about RDA fundamentals. We'll have a brief introduction, and then we're going to spend time about RDA Studio, and then whatever we perform, how we publish those data automation pipelines to Fabric platform, how they would look like while running in production, etc. Followed by the labs and doing all the lab exercises. Okay. So we briefly talked about in yesterday's sessions, part of the introduction, but let's just go through again. What is RDA? RDA stands for Robotic Data Automation, which it enables seamless integration with any data source within an IT environment to perform key operations such as data ingestion, transformation, enrichment, filtering, and routing. And the processed data and the transformed data can be directed to various destinations for different use cases, such as analytics, machine learning, notifications, and more. RDA delivers each data automation function as a bot. Multiple bots can be seamlessly stitched together in a sequence to accomplish end-to-end data automation tasks. So we're going to talk about how these are built, developed, and tested and validated. So the RDA Fabric platform is designed to be data-centric, addressing the complex data challenges associated with adopting and successfully implementing AIOps solutions. To ensure the success of AIOps adoption journey in production environments, it is very crucial to have a robust data automation mechanisms in place. These mechanisms are basically facilitated through RDA pipelines. So to make it successful, to make it efficient, it needs to have a comprehensive DevOps style approach, which ensures a continuous testing, validation, and deployment to ensure the pipelines function very effectively in dynamic environments. In order to support this, CloudFabrix provides the RDA Studio, a development environment built on top of Jupyter Notebook web application. RDA Studio integrates with the core RDA Fabric platform, empowering the users to design, develop, and refine the RDA pipeline seamlessly. So the RDA Studio allows for extensive testing and validation of pipelines in a controlled setting and ensuring their reliability and effective before they are deployed in production use. So this can be iterative development process in order to reduce errors, improving the performance, and accelerating the deployment of production-ready pipelines, thereby enabling a smoother and more effective AIOps implementation. So what is a RDA bot? A bot performs an atomic task. Bots are repeatable and they are reusable. Bots are chained together in a sequence with other bots. You have the data input into the bots, the bots automates the data, transforms the data, filters the data, and finally routes the data to target destination. We have many categories of these bots. We have ML bots, collaboration bots, data automation bots, which deals with the raw data. We have the integrations with databases, files, ITOM tools, ITSM tools, infrastructure, and many. We have 1,000+ bots. Let it be data automation bots, infrastructure integration bots, ML-related bots, collaboration bots, streaming bots, and whatnot. Some of the examples I've highlighted here. We have integration with the App Dynamics. So the bot notation, something would look like this. You have the source name, and then the bot, what it performs, integrating with that source. In the context of App Dynamics, this bot represents, getting the health rule violations from the App Dynamics APM environment. If you want to post a Slack message based on certain condition, escalating certain operational issue, your L3 team or on-call team, you can integrate with Slack, and it lets you to automate the notifications. Integrating with AWS, you'll be able to get the inventory of all of your EC2 instances. As part of the data automation, if you wanted to do the data translation from JSON to XML, XML to JSON, you have a bot. All of these tasks and functions are encapsulated in the form of tiny bots, which are composable, and putting together, you can perform end-to-end data automation. What is an extension in RDA? An extension is nothing but it facilitates the data integration with a particular data source, enabling the data collection via pull or push mechanisms, or transmitting the data, meaning process data, transform data to the target destinations. Some of these data sources are VMware vCenter, Kafka messaging, email, network devices, databases, ITSM tools like ServiceNow, monitoring tools such as Zabbix, VROPS, and whatnot. Within each extension, it will have one or more bots. Each extension bot automates authentication with the source or the destination, API session management, pagination, and formatting the data in the nicer format, like flattening the structure from the complex data structures into a simple tabular format. These are some of the bot examples, integrating with the different sources. When you have integration with the VMware vCenter, for an example, how the bot look like. This is the kind of notation it follows throughout the RDA framework. Each bot integrating with a particular source represents with the source name, which is nothing but when you add the source credentials in RDA platform, you give a credential source name. So that represents that the credential represents that source integration, followed by all the bots available within that source integration. So in this case, we have vCenter integration source, and these are the bots it has, and much more. We just captured just the examples. Similarly, you have the Kafka source for streaming the data. You have the Kafka source on the left side, followed by with column. You have the Kafka bots, like listing the topics, altering the topic, reading the data from the topics, writing that data to the topic. Similarly, you have the ServiceNow, the corresponding bots, and you have the email integration, the corresponding email bots, and then Ansible automation, and then followed by what bots you have within the Ansible data source integration. So in principle, there are three types of bots. So these are the three separate categories. We have the source bot, which does the data collection from different sources, either pull or push. Either they are collected from external sources, integrating with different sources or the destination, or loading the static data through files, or feeding the static data by manually entering the data by the users. So these are all referenced as source bots. And then update bots. Update bots does the data transformation, data enrichment. So they take all update bots that they take the data from the previous bots as an input, performs the data automation, whether it's a transformation, manipulation, filtering, or enrichment, and the transformed data will be transmission to the following bot. And then we have the sync bots. Sync bots are primarily used for the data transmission into the target data sources. What is the bot syntax notation? As you can see here, in an RDA pipeline, the pipeline, when you use the bot, it starts with this double dash arrow notation. It represents a new line with a new bot. And the bot has these symbols, @ star or hash, which represents the type of the bot, whether it's a sync bot or source bot or update bot. And then you have the source name, whether it's a vCenter or a Javix or Ansible or Prometheus or VROPS and whatnot. And then you have the actual data collection bot or a data processing bot. In this example, we have a bot called vCenter Summary, which connects to the vCenter, collects the vCenter Manager configuration data. Now let's drill down into source bots. So source bots, we talked about, they primarily collect the data. And source bot examples we have given here. One is collecting the data from sources such as vCenter, the management tools. And then, reading the data or streaming the data, from the alerts, events, logs, incidents coming from the external sources, or loading the files, like a CSV file or Excel file, or creating the empty data set, which is a bot. Let's say you wanted to start with empty data and add the data as you build the data automation pipeline. So here, these are the things, some of the examples we have highlighted here, like creating an empty data set, loading a file, reading the data from database, and from an API endpoint, any integration, or reading the data continuously, and reading the tickets from ITSM tool, and reading the metrics from observability tool. So these are some of the examples which represents source bots. Let's talk about update bots. Update bots have, these are the examples. Update bots, as I explained, they take the data as an input and they transform the data and they transmit into the next bot. So these are some of the examples. DM represents data management. Data management bots are available, and which does all the data transformation, such as filtering the data by applying some queries, and what columns are nothing but fields you want to select, like include or exclude. You want to fix the columns in transforming the columns if they have any special characters. If you wanted to normalize the columns, you want to enrich the data, taking the data from one source and enriching with some other source. And then changing the data types. You want to change the data types of the incoming data columns from string to integer, integer to float, vice versa. So below are some of these examples, like filtering the data, selecting subset of columns, computing new columns, which means based on the data within existing columns, you want to derive new data into the new columns. Fixing the input data, like you wanted to lowercase all the data or uppercase, you wanted to find and replace all of those operations. You wanted to perform aggregation, grouping, calculations, and enriching the input data using a dictionary, which means enriching the data from a different source. Converting input data types, validating the input data, and if you wanted to collect the random sampling from a streaming data such as logs or events. And another advanced use cases such as if you wanted to perform ML by applying NLP bots, extracting the sentiments based on the open text. We can perform unsupervised clustering, classifying the input data, predicting the time series, and all of these operations falls under update bot category. And then we have the sync bots. Sync bots basically takes the data as an input and persists the data, either into memory or to a target destination like a database. So these are some of the examples. DM save name inventory underscore data, which means it saves as a data set and persists the data into object store service within our platform. Writing the data into a stream, which means it is publishing the data either through a messaging bus destination such as NAS, RabbitMQ, Kafka, and any streaming technologies. And then creating a ticket, basically taking the alert data, correlated data. Now you wanted to take the data, transform data, passing that information to ServiceNow by creating a ticket. You want to post a notification through HTTP post, like webhook. So you have the REST client bot. So this is considered as a sync bot. And then posting a message to Slack, sending an email. So these all type of these bots are considered as sync bots. So these are some of the examples highlighted here. Saving the data file like a data set or JSON. Saving the data to MariaDB, MySQLDB, or SQL Server destination. Sending the data to an endpoint like API, HTTP endpoints, and sending the data to a stream, and opening a ticket into an ITSM tools, and sending the data to S3 service or the data lake. So these are some of the examples which represents the behavior of these bots, and they categorize these bots either source bot, update bot, sync bot, based on their function and capability. So what is an RDA pipeline? So RDA pipeline is a sequence of bots that is ingesting or collecting the data, transforming the data, and sending to one or more destinations. As you can see, the anatomy of a typical pipeline. You have a source bot, which is getting the data. And then the data is transmission into the update bots. The update bots transforms the data, cleanses the data, enriches the data, adds more context to the data. As part of this, you can use one bot or more bots for the data transformation. Finally, the transformed, enriched data, contextualized data is sent to the sync bot, which persists the data or sends to the target destination. Here is an example of RDA pipeline. So each line, which starts with, for example, with this special characters at the rate or star or hash, represents a bot. You have the file spot, which is loading a file from an URL, or you can upload a file and you can point to the path. And then the file content is loaded, and passing that loaded content as an input to machine learning bot. Bot name is log clustering. It performs the unsupervised clustering based on the data into the file. It generates the grouping. And then you're applying the data management filtering bot, looking at all the group clusters, which identifies the messages that look similar, by grouping. And you wanted to select those grouping which are not anomalies. Once you get the updated data, finally you are saving to a data set. So this is a typical fundamental data automation flow within RDA platform. So what is CFXQL? So this is one of the very important aspect within our platform. CFXQL stands for CloudFabrix Query Language, which abstracts the technology-specific query language into a unified, normalized SQL-like syntax. The syntax and notations of CFXQL remains consistent regardless of the underlying data sources. So what I mean with that? So RDA platform integrates with a NoSQL database like Elasticsearch, RDBMS technology like MySQL, and other sources, DB sources, and which supports source filtering, right? So each of these technologies, they have their own query languages. So, but once the data comes into the platform, you cannot expect the user to know each and every technology's syntaxes to transform the data, filter the data. So for that, we have come up with a unified query language, irrespective of where the data comes into the platform. You will have the unified experience of maintaining that queries consistently across your RDA pipelines. So in CFXQL, what is the syntax format? You have fundamentally, two notations. One is the actual query, a SQL-like query language for data retrieval, right? For example, when you use the column names in a part of a data automation, they must be alphanumeric, and the underscore special character is recommended. If there are other special characters are used, the column name must be escaped with backticks. So for simplification, so this is just a recommendation. After the query, you have the result format. Okay, you apply the query, you get the data. But within the data, you are interested in a specific set of fields. You can select the specific columns or the fields. Part of the session, we are going to use the fields and columns interchangeably, but both are represent same. If you want to define the order of the columns, you can define part of the result format, syntax. And as you're getting the data, certain columns or fields, you want it to rename, to represent in a particular form. So these are the two, syntax, specific, formats which CFXQL supports. The CFXQL notation is used, throughout the RDA pipeline architecture. So here are some of the examples. We have a very good documentation. The documentation link is provided here. So how a typical CFXQL query would look like. You have the data management filter bot, which uses a CFXQL and many other bots. And then you have the CFXQL query. In this example, I wanted to filter all the network devices where the device category is switch. And the data source is coming from either logs or alerts from the network infrastructure where the severity of network devices is not in info or debug. And I wanted to get all the alerts where the status is not closed. So you can have a simple query as with one filter, or you can combine with other fields like and or, combination of and or. You can go as you can start with simple to complex. Once the filter is completed, getting the data or filtering the data from the output. This get the result format is optional. If you don't use this, it gives you the full column data without filtering the any fields. So get allows you to filter the columns. out of the result, I'm interested in only device underscore category, severity, but status, I wanted to rename it as incident status. So this is the example of the syntax and formatting example of CFXQL. So this is consistent across RDA platform. When you query the data from integrating with the MySQL or integrating with Elasticsearch, integrating with the Splunk, or integrating with any other database technology where the query language supports at the source, you have the common query language using the CFXQL throughout the platform. So it supports different operators. It supports equality operators. So these are the examples. And you have the numerical operators, and then you have the string operators. When it comes to CFXQL query search types, so there are two types. When you integrate the data and fetch the data from the sources. Searching and filtering the data at the destination. So what it means is when you retrieve the complete data set from the source into the RDA platform and search or filter the data using CFXQL. So this approach is used because the source does not support searching or filtering the data during retrieval. So for example, you're collecting the data from a Linux host OS or vCenter. These sources natively doesn't act as a database. You make an API call, they provide you all the data which comes out of that API response. So you get the data, the complete data into the destination, which is RDA platform, and then you can apply the filter using the CFXQL. So if the source provides you 100,000 records, so you need to get 100,000 records into the system first, and then you can apply the filter. So during this process, this entire data set from the source is maintained in memory until the RDA pipeline is completed. So the memory consumption increases based on the size of the data set and the number of data transformation steps involved within the pipeline. So the other type, search or filter the data at the source itself. So when you retrieve the data into RDA platform, you apply the search or filtering at the source itself using CFXQL. Let's say you're querying the data from a database. So you use the CFXQL. What CFXQL does is it translates your query from the CFXQL into the native query, depends on the backend technology. This approach is very, very efficient because it fetches only the required data and the resources will be used optimally. So some of these examples are databases such as MySQL, Oracle, Elasticsearch, OpenSearch, Splunk, etc. So data frame in RDA, what is a data frame? So a data frame is a two-dimensional data structure that resembles a table consisting of rows and columns. In the RDA platform, data is processed and transformed in the form of data frames. As the data comes into the platform and the data is processed, transformed, enriched, all of these operations happen in the form of data frames. You get a table of records in the form of rows and columns. As you can see, you have the columns and you have the values. So these data are transformed as they process through these bots. So this whole data structure is referred as a data frame. So what are data sets in RDA? So there are two types of data sets when they are used within the RDA pipeline. There are temporary data sets and then persistent data sets. When you use temporary data sets, so these are maintained in memory itself during the execution of an RDA pipeline job. The data for temporary data sets is isolated when multiple instances of the same pipeline are executed. What I mean by that is you create a pipeline to collect the data and transform the data using enrichment and using other transformation bots. When you use the data in temporary data set for subsequent data automation within the pipeline, and when the same pipeline is used in multiple times, for an example. So the data which is maintained in the temporary data sets within the pipeline job, they are isolated. So they are independent between the pipelines, even though the executed pipelines are coming from the same source pipeline. So the temporary data sets can be recalled or reused within the same RDA pipeline, one or many times. However, since they are temporary data sets, they are restricted to within the context of that pipeline. They cannot be recalled across different RDA pipelines. So how that these temporary data sets are defined when you use within the RDA pipelines? The notation using temporary data sets, which starts with temp dash. When you say DM save, which is the data management save bot as a data set, when you specify the name starting with the temp dash and followed by some text, in this case example server underscore inventory. So this is the data is saved into this one as a temporary data set, which maintains inside the memory. Then we have the persistent data sets. So these data sets are persisted and saved into the object storage service MinIO of the RDA platform. The data for persistent data sets is not isolated when multiple instances of the same RDA pipelines are executed. The reason is it is persisted when the two pipelines are calling that data sets or writing. It is coming from the same backend source, which is the object store. So obviously, it's not a good idea to use the persistent data sets if you wanted to make a change and running through different pipelines. So the reading the data set and using different pipelines, that makes sense because you're reading the same source. But writing, it is not a good idea because it conflicts and causes the data corruption. Persistent data sets can be recalled or reused within or across the RDA pipelines. So the reason is, unlike temporary data sets, these are persisted when you recall, you're recalling from the external a data source such as object storage. So as I explained, when you try to use across the RDA pipeline, especially for writing the data into a data set, you should be carefully considering that. Depends on the specific data automation use case. Persistent data sets data can be visualized or analyzed offline using either RDA Studio or RDA platform portal. So the bot notation for persistent data sets, using the same DM save bot, don't use temp dash, and you can use any name, and which will be saved as a persistent data set. So what are the control blocks within the pipeline? Control block represents the beginning of the data automation block within an RDA pipeline. So when you start this control block, the first bot within the control block should be a source bot, like querying the data from a database or getting the inventory from Linux, getting ticketing data from ServiceNow. Those are the examples. So the collected data from the source, the data as a data frame will flow through each bot within the control block. And within this control block, I mean, like the data which is automated within the control block will not flow through another control block within the RDA pipeline until you save the transformed data within that control block and recall it within another using the recall data frame bot. Within RDA pipeline, you can have one or more control blocks. We'll talk about when we do the exercise, we understand what this means. So within the control blocks, we have different types. We have a standard control block, which is a new block, which is the default one. And then we have the flex block. So the difference between new block and flex block is new block is a default one, which has a strict notation of when you wanted to use a source bot, it has to be as a first bot, within this new block. In certain use cases, it comes as a limitation. So for that, we have flex block, which allows you to use a source bot in any position of the RDA pipeline. So it doesn't have a restriction of using the source bot only as a first bot in the control block. And then we have the data loop control blocks, which are primarily used for the data looping automations. We have a simple loop, we have the data loop, and we have the count-based loop, timing-based loop, and then bookmark or checkpointing-based loops. So these are some of the examples we have. On the right-hand side, you can see one quick example of this control block, which starts with the standard one, a new block, and then you have a sequence of bots within that. So the data starts with an empty data frame, and then we are adding one field or column with a description, some text, and we are giving that input to the sentiment analysis bot, and it does the job of ML what it's supposed to do, and finally the result is saved to some temporary data set. So this whole flow concludes the data input, transformation, and the destination of saving either into memory or as a persistent data set. If you wanted to start the new control block and to get the data from different source, so obviously this whatever the data you're saving here, it will not by default transferred into the new control block. If you want to use this, you need to recall this a particular data set into the new control block to get the data that you have within this one. We have if-else condition to have a conditional flow within your RDA data automation pipeline. So even though we call it as if-else condition for better understanding, it's basically if bot with a conditional support. There are two types of if condition you can use. One is the CFXQL based, which means you can apply a filter based on the incoming data. If there is a match, it will go inside that block. And you don't want to apply the condition based on the filter, but you wanted to make the decision based on the number of records in the incoming data frame. If the number of records are, let's say, more than 0 or 1 or 2, you wanted to go inside the if block. So if you whenever you use if bots, if else bots, it supports the nested as well, which means you can have if condition within another if condition block. So from the data flow point of view, right, as you can see, you have a data frame 1, which is coming into the if condition block as an input. You apply the CFXQL filter here. If there is a match, it goes inside and it creates a new data frame. But when the block comes out, whatever the input is into this block will come out as output. Whatever you have inside the block stays inside the block. So until you save it and recall it if you wanted to reuse it inside the pipeline. So these if conditions will have in especially in routing the data. Let's say you wanted to route all the critical events, let's say sending a Slack message or Teams or email, you can use this condition. Anything else will skip through this if and continues with the data automation. So here are some examples here I've highlighted, CFXQL condition based, and then the data frame shape based condition. So here I'm loading a file and I'm applying a condition if the message contains config. So it looks up into the message field, and if it has a text called config and it satisfies the condition, and then it goes into the if block and it saves the data set. And you have another example, and here you're applying a filter outside of this. If there is a match, obviously it will have some records. If not, it will have 0 records. If it has 0 records, which means it doesn't satisfy this number of rows greater than 0 condition, so it doesn't go inside. If it has at least 1 record, then it goes inside and it applies this additional bot by adding another column, and it saves as a temporary data set. So these are the simple 2 examples that you can refer when it comes to how to use the if-else condition. And then we have the data loops. We have simple loop. It basically loops through the specified comma-separated values within a control block. For example, in the right side, I've given one example. You're using this simple loop control block with a loop variable. You can type any name here, just a string, and then you have the comma-separated values. And it takes these. Here we have specified 2, which means it goes through this loop twice. In this example, what we are doing is we are taking that loop variable as an input and passing it to Hitachi bot to collect the LDEF, and then finally you save in temporary data set. So obviously, you're looping it and you're saving as a temporary data set. If you give the fixed name here, it will override the data. That's why what we are doing is we are using the dollar variable, which substitutes the value what you specify here. And then we have the data loop, which loops through the specified data set columns, processing them row by row. So what it means is, unlike simple loop, a data loop takes a one of the available previously processed or used in a data set within the RDA pipeline. It can be a temporary data set or it can be a persistent data set. So here, what we are taking is we are taking a data set name called snow incident tickets with stats. Within the data set, we wanted to loop it through based on this column or attribute, attributes alert source. So if it has 2 records, it will loop through 2 times. If it has 10 records, it will loop through 10 times, and it goes through this block. It does whatever you configure here, applying the filter, data transformation, and finally saving them as a temporary data set. So when you have the temporary data set, when you're looping in, especially using this loop blocks, you have something called append. When you do the append, as long as your data model is same, you can use this option, which means it will keep appending as newer data is coming in by looping through the data based on the values within this attribute. And then you have the count loop. It's a pure count-based iteration, looping through the data and based on the increments, and you can specify what is the start number, what is the end number. And then you have the time loop. Time loops is basically iterates through every certain specified time interval. And then we have the bookmark loop, and bookmark loop iterates through the data by tracking the last processed row or a record, and processes only the newer data by checking by keep tracking of the checkpoint, either timestamp or other field within the data. These bookmarks are persisted in MinIO service with the last checkpoint's value. For example, in this case, we are taking the timestamp as a value. As you're getting the newer data, the newer data has the timestamp value that it will take the last records which it yielded into the pipeline. It takes that timestamp. It will keep track of that. In case the pipeline fails and it restarts after a failure, and instead of missing the events, it will restart from the last checkpoint. So this is bookmarking is useful in such scenarios. So when you use these fields in the data loops, right? So they are referenced the field name with this dollar notation, where the actual value will be substituted, during the runtime. So when you use these are some of the caveats. When you use the data loops control blocks, obviously they don't support nested data loops when you use these control blocks. So you cannot use multiple data loops, within this data loop. And we have the for loops, right? Unlike control block based data loops, for loops can be called within a control block, and they do support nested looping as well. For loop supports you can specify the number of rows. It takes the input data set, and it takes based on the number of records, you can choose how many you want it to process. Whether you process 1 at a time, 2 at a time, 10 at a time, it goes into the loop, based on the condition and based on the data that you have. So as I mentioned, nested for loops are supported, which means you can have for loop within the for loop. So when it comes to the data substitution, right? So as the data, you're getting the data through looping, and you wanted to use the input data, but as you're looping through, you wanted to use some of those values as a variables, right? So in case of these for loops, we use a Jinja2 type template notation to represent those field values. You can see the field values are represented as a row dot the actual column name in this flower bracket in notation. So these basically addresses simple to complex use cases, and these can be used where it is needed. And as you can see, one of the example of Jinja2 example here, it's not a for loop example, but this is an example for the Jinja2 notation. So basically, you have a input data frame with a two columns, A underscore ID with some value, and then you have a parent column with the VROPs. So you wanted to pass these values as a input to the CFS query to this query persistent stream. I wanted to query the persistent stream based on these inputs, right? So so these inputs are statically given, but in a real world automation pipeline, these can come from the incoming data set as well. So these are configured as a Jinja2 style notation, the row dot A underscore ID. So this value is substituted with the value that you specify here during execution time, and it applies that CFSQL query, and if the records matches, it gets the data and pass it to the next step. And then we have the retry loops. So retry loop, they work like functions, like a try-catch mechanism with built-in retries before the exception is handled. In the sense, some of these source pods, let's say you are querying the vCenter, but because of some HTTP timeout, it fails. So some of the bots has the built-in retries, but if there are bots doesn't support those retry mechanisms, we have a generic approach of supporting the exception handling using these retry loop bots. You can specify the retry loop, and you can specify number of retries and how frequently you wanted to try by specifying the time and the number of times. And then you can execute the actual bot. So if there is an exception because of timeout or something else, it waits for the specified time and it retries a number of times. And then it also supports calling function we'll talk about in the further slides. But this is a very useful bot which can be applied across any data sources which doesn't support these retry exception handling mechanisms. And then we have functions bots. This is to address some complex use cases. But by definition, these functions will allow you to define a data automation block as a function once, and they can be reused and recalled within a RDA pipeline many times. This primarily helps simplifying and organizing the pipeline, making a data automation management more efficient, also to address some complex use cases as well. So some of the available function bots are, we have the define function and end function, within which you basically define a sequence of bots and put together, and they will be called as that function, which can be recalled using the call function. Return function basically returns the output coming out of the calling that function. So these are the simple examples here how you define the function, and you're using some evaluation bot. So when you call the function part of a pipeline, it passes the data frame as an input to this function, and performs this necessary data automation, and it gets the output back into the RDA pipeline. And this is how you are recalling it and passing the data inputs to that function. And we have the data transformation bots. So we have the some of these column transformation bots we have, like DM fixed columns, right? Data management fixed columns. So it primarily addresses if columns have any unsupported special characters, and replace them with underscore automatically. Let's say if you have 100 columns, there are some spaces, some special characters like @ or percentage or clashes. You don't need to go through 100 columns and cherry picking and fixing it. Rather, you just use these fixed columns. It just addresses it one shot across those columns. And then you have the select columns, right? Out of, let's say, if your input data set has 100 columns, but you're interested in only 10 columns, right? So you can use this bot to simply filtering the columns. So it has simple include and exclude parameters, and which both supports a regular expression format as well. You wanted to rename the columns, right? So you wanted to normalize all the input data set using the rename columns. You can name however you want in a structured format. Add missing columns. Let's say if your input data set is having 10 columns, but you wanted to add additional column. Or part of the data automation, sometimes the data can be dynamic, right? So when you query the data, you'll get 10 columns, but when you query the next time, depends on the data, you get only 9 columns. So one of the column or more are missing, right? Part of the automation, you wanted to make sure that some of these columns exist part of the pipeline as a mandatory based on the complexity of the data automation that you apply. So this add missing columns will help you by adding that missing column dynamically if that doesn't exist part of the incoming data set. So these are some of the simple bots, but there are many which we can explore part of the RDA Studio exercise. And then we have the actual value transformation. DM enrich is one of the very widely used bot. It enriches the input data frame or the data set by adding additional columns. It performs a lookup into another data frame or a dictionary data set, which could be coming from different data source, using a specified source and dictionary lookup columns as keys. If there is a match, the specified columns as enriched columns from the dictionary will be retrieved and added to your input data frame or data set. And then we have the fixed null. Let's say if the data that you're getting has some null values or nan values. I think if you're a Python programmer, you would understand these, especially in the Python language. So you wanted to fix those null values with the empty string. So empty string in a data world is still a valid string. So you wanted to deal with the fixed nulls, you can use this bot. Or either you leave it as an empty string, or you wanted to apply as a fixed static value. Let's say you wanted to specify, okay, yeah, if there is no value, you wanted to tag it as a not applicable. Right. So that is a simple example. And then we have the data map. Data map basically transforms the actual data, supporting many functions such as you wanted to lowercase the data or uppercase the data, you wanted to transform the milliseconds of timestamp into ISO format or vice versa, converting the UTC time zone to IST time zones to European time zones and whatnot. You wanted to find the data and replace with certain fixed values. You wanted to clear the white spaces using the strip function. So there are many functions such that there are available. You want to mask the data. Let's say if there is sensitive data part of the data automation, and you want to mask the IP address or the usernames or the email addresses. All of those functions are available part of the DM map. So in the RDA Studio, you can look at help text of the DM functions to see what are the supported functions. And then we have the DM evaluate function. It's a very, very versatile data transformation bot which supports simple to complex Pythonic expressions. It will make it very highly powerful when it comes to data automation. It enables within that expression if you have conditional based data transformation for flexible and dynamic processing. Here is a simple example. I wanted to derive a vendor name based on the data out of a product name is one of the field. So if it has a if it has a vSphere string within the product name, I wanted to tag that product as a VMware product as a vendor name. If it has a Cisco, I wanted to label it as a Cisco. Or you can have the complex if-else condition in a number of ways using this Pythonic expression using the eval bot. And then let's say if you wanted to convert the timestamp from the milliseconds to ISO time format. So this is a simple function. So right side I've just captured so that you can look at what are the different functions are available and how they are used within this eval bot. And then we have the streaming bot. Within the streaming bots, we have two types. One is the read stream and the write stream. Read stream bots reads the data and ingests the real-time data as they are arriving into the RDAF platform by integrating with the streaming sources. The data is ingested yielded either by waiting for a specified time interval or by reaching a particular batch count. So you can specify I wanted to yield the data as the data is coming in every 2 seconds, or if the number of data points reaches nothing but batches like 100 or 1000. So as soon as one of the condition matches, it yields the data and pass the data to the upstream bots. So these are some of the examples. You have the at RN within the platform. RN represents RDA network bot, which utilizes the NAT messaging service for publishing and subscribing the data communication. And then we have the DN bot, which represents the data network read streaming within the platform. It employs the Kafka messaging service for publishing and subscription data communication. And you have the external source integrations like RabbitMQ, right? Reading the stream, which means like reading the data from RabbitMQ message queues. If you have external Kafka cluster, it has a Kafka integration. It does the similar functionality. So we have the write streams. Write streams ingest the data as the data is coming into the platform, getting transformed or enriched. They will be written into the target destination using these bots. Similar to read stream, we have the RN bots, RDA network bots, which utilizes the NAT messaging service, and then we have the DN bots, data network bots, writing into the Kafka topics. Similar to our platform, we do support external message queues such as RabbitMQ or Kafka as well. So how the read stream data flow happens, how the flow would look like. So read streaming bots yield the data in batches and iterate through in a loop within the control block. So as you can see here, this is the control block, right? So we are using the read stream as a starting bot and specifying what is the stream name, and then we are giving the consumer group. So hope you understand the consumer group concept in the PubSub messaging world. So you have the batch count. So here, either the default timeout is the wait time is 5 seconds, or the batch count 50. It yields the data, and then it passes the data to the subsequent bots like DM filter, selecting columns, and writing the stream, and gives the control back to the read stream again. The data being read, processed, and gets the control back to the streaming bot. So it goes in the loop. So there is one caveat here. So if there is a need to process the streaming data across multiple control blocks, right, for simplified or a complex data processing, so because of the limitation, you need to consider using a parent-child RDA pipeline configuration, which we'll talk about as we go through these slides. Okay, what are persistent streams within the platform? We briefly talked about yesterday. So let's revisit in a little more details here. As the data is coming into these streams using the read stream bot or read stream capability of the platform, RDA collector service, it captures the incoming data into these streams and it persists the data into the index store automatically. So this index store is backed by the OpenSearch service. So how do you manage this? You go to configuration, RDA administration, persistent streams. This is where you create the persistent stream. When you create the persistent stream, there are two modes are available. By default is the append mode. It's like a time series data. If you wanted to create a piece stream for a specific use case, such as inventory or alerts incident, where you maintain the unique records and update the records as the data changes to the same record, you need to configure it as an update mode. When you configure an update mode, you need to define the unique keys, so which will identify the unique record, so that when there is an update to that record, it identifies by the unique key and updates the record. So different settings are available piece stream. There is a documentation available, but here is a quick example. And this piece stream setting represents an update mode piece stream, where we are defining the unique underscore key, unique underscore ID as a unique keys. So it is an array. You can have one or more fields as unique keys, and then you have the index level, piece stream level settings, number of shards, replicas, how frequently you wanted to index the data, refresh interval and whatnot. So within the persistent stream, we have many data automation bots, and so these are some of them. Let's say if you wanted to create a persistent stream through the pipeline, there is a bot, and then we have the querying the data from the persistent stream. So you have the DM bot, and it is widely used for querying the data, from different piece streams within the RDA platform, part of the RDA pipelines. And then within the query, let's say you wanted to, if you are querying a larger amount of time, you wanted to iterate through in chunks, so that the data can be efficiently managed from the memory and processing point of view. Either you can do by time or you can do by the data chunks. And within the persistent stream, we have the bookmarking. So using the bookmarking, you can query the data from the stream, and it captures the last checkpoint based on a timestamp and other fields, and iterate through the data in a loop. And also you have an update update the piece stream data by query. Let's say you query the data, and let's say you have 1,000 records. You query the data, filter the records, 20 records out of it, and you update only certain fields on the filtered data. So you can use this update data by query bot. If you wanted to delete the data from the piece stream, you can do the similar way. you can query it using the CFXQL. Make sure the filter is working and it is yielding the results that you're looking for. And then you can pass the same filter to this delete data by query. And then you have the enrich using the P stream. Let's say you wanted to enrich the data based on the data in the P stream. You can use this bot part of your RDA pipeline. So these are some of the examples for the query persistent stream bot. There are two examples we have given. You can just query the data and you can sort the data and you can selectively cherry pick the columns you want from the filtered data. Basically, the query persistent stream supports source filtering, which means the data is filtered at the source itself before you get the data as an output. So in this example, we are querying a persistent stream called OAA alert stream, and then we wanted to filter the data by source system name like VROPS. Once the records are matched, we are interested in only these particular fields like source system name, status, incident ID, and created timestamp. And I wanted to limit the data up to limit 10. I don't want to get in all of the records that matches this query. And in the result, I wanted to sort by the column created timestamp, and the sort type is a descending order. So this is one of the simple example of how to use the query persistent stream against the data which is persistent in these streams. On the right side, you can see the sample output. You can also use the same bot to query the data, and you can perform the aggregations. Again, these aggregations happens at the source, which means you send the query using CFXQL that is translated into the native query, and the source system, in this case the OpenSearch, it does the aggregation for you and it gives you the output. Here you are basically aggregating by the source system name and status. I wanted to know within the VROPS how many active alerts are there, how many cleared ones are there. And a P-stream bookmarking bot. So this is one of the useful bot if you wanted to iteratively yield the data, based on the data is being persisted into the P-stream based on the checkpointing. So basically, it reads the data from P-streams iteratively while tracking the last fetch record using bookmarking, or also referred as checkpointing, and retrieves the new data from the last bookmark onward. So even if there is a failure of the pipeline, obviously it restart the pipeline from the last checkpoint, so that it doesn't miss any data records from the P-stream. So this bot is very useful processing the data from the P-stream in streaming mode and ensuring no new data is missed in the event of RDA pipeline failure or during a restart. So as I explained, it resumes the processing from the last bookmark checkpoint. So this is an example. You have the bot, and then you have the P-stream name from which you wanted to keep querying it, and then what is the bookmark name where you wanted to track the checkpointing, and what is the initial query you wanted to apply to query the data. And as the data gets queried, it flows through your data automation flow here using different if condition, implode bot, evaluate in if condition, enriching and whatnot. And it waits for, at the end, it waits for 5 seconds. It gives the control back to the streaming bot here. And it goes through in loop as the data is coming in real time. Okay, so parent and child pipeline. So an RDA pipeline can invoke another RDA pipeline or multiple pipelines in a sequence. So you can have one pipeline and it can call another pipeline within the same pipeline. So the data flows between RDA pipelines in sequence similar to the bots. So for example, here I have a parent pipeline here. I am processing the ServiceNow inbound notifications here. As the data is coming in, I wanted to filter the data by resolved or closed or cancelled tickets. Since processing the data, it takes much more than few steps, and it requires multiple control blocks. What I'm doing is I'm calling another pipeline which has further automation of these inbound tickets to take certain data automation tasks, using the multiple control blocks. So when it calls this child pipeline, whatever the data it gets here, it will pass as an input here to the child pipeline. How the child pipeline picks the data input from the parent pipeline. So this child pipeline always starts with this particular bot at @exec get input. So when these two pipelines are running in runtime on a worker, so this bot understands the process of how to query the data from the parent pipeline input data and passes into the further bots within the child pipeline, and the data gets processed. So how to call the pipeline? So you have this bot in exec run pipeline, and you give the pipeline name. So obviously, if you're running a published pipeline, make sure both parent and child pipelines are published. We'll talk about published versus draft pipelines in a minute. And here we have the formatting templates. So formatting templates are very powerful part of the notification, or while opening a ticket in a certain format, prettifying the data output, right? So RDA utilizes the Jinja 2 templating engine to format the data, so which makes it very suitable for REST endpoints and HTML reports sent via email or while opening a ticket, and posting the alert data or incident data in a prettier format. So these templates, these formatting templates are consumed by these two bots. We have an apply template by row, which applies this template for each record, and you also have apply template for all of the rows within a data frame. So this is a simple example of formatting template. You have the Jinja style notation here with HTML body, and these highlighted fields are the actual columns. These columns values are substituted when you recall this formatting template using the bot within the pipeline. For example, this is the pipeline. Okay, I have a simple data frame where I have created a service node ticket number, a priority, a state, a short description, and a description. When I pass this record as an input to this formatting template, and you can clearly see how this data is formatted applying this formatting template. So these incident priority and all of these labels are predefined here, but these values of these labels are substituted part of this RDA pipeline by applying this apply template by row bot. So while the platform provides a lot of bots, a lot of integrations out of the box, and each and every release we are adding more and more integration, but we also support SDK-based bot development. So how to access the SDK, how it works, and the examples are captured in this documentation. Right now, we are primarily support Python and the Golang. Java is in the roadmap, even though it's specified here. So leveraging this programming languages using our RDA SDK framework, you will be able to build your own bots, and those bots can be used part of the RDA pipelines, along with the bots that are available out of the box.
Yeah,
so with this,
we'll take a break here, short break, Mani.
Can you see my screen?
Yes.
Okay, so we're going to go through the RDA Studio, the application, how it looks like, how to navigate through, and then followed by our RDA Fabric platform UI, and then we'll jump into the lab exercises. So as we briefly talked about, RDA Studio is an application is built on top of the Jupyter Notebook web application. It is a standalone container service which can be deployed either on Linux, Windows, or Mac OS, as long as it has connectivity to the RDAFabrix platform over the network. How do you access the Studio? You can access through web browser. You can type in HTTPS and the IP of the Studio. In this case, your RDAF VM IP and the port 9998. This is a default port, and if needed, it can be configured port 443 as long as it doesn't overlap with some existing application on your system. So when you open this, this would be your launching page. Then how do you start the Jupyter Notebook? So you can click on either this one, or you can go to the File and New menu, and there is an option to open in Notebook. So CFXDX represents the RDA Studio service. Once you launch this, you will get a cell here, and then you need to type the function like Studio here, as it is being shown in this slide. Studio open close parenthesis is Shift Enter or Option Enter, depends on the operating system you can use, or you can hit the play button here. And this opens up the RDA Studio application, and you have the menus here. You can drop down, you can navigate through those menus. So when you drop down, so these are the different menus are available. I've just highlighted some of the important ones. If you wanted to add a pipeline or update or delete a pipeline, so you have these action menus. If you wanted to search the pipeline content across all of the pipelines, you have one option here, search pipeline content. If you wanted to check the RDAFabrix platform access, you can use this option, which validates and shows RDAF platform access. And then if you wanted to export the pipelines and import into another RDA Studio, you can use this export and import option. If you wanted to explore the data sets, the persisted data sets, which are saved in the S3 service, the object store service of the platform, you can use this option to explore the data sets. So one of the important option is adding or updating or deleting the source integrations, like adding the source with the credentials, which enables the corresponding bots into the RDA Studio or the RDAF platform. So this is the option you can use. Adding the source integrations. So as I was showing in the previous menu, go to this administration, manage bot sources, click on this add tab, and then you will get the drop down list of all of the integrations. Once you select the source that you would like to add the credentials, you will get a form like this for that source, which the fields are relevant to that source. In this case, in this example, I have chosen Linux inventory, which is asking the IP address and the username and password. It supports the SSH key also. In this case, in this lab exercise, we are using the username and password. You can specify the port, and you can click on the check connectivity. When you click on the check connectivity, it not only validates the network access, it also validates the applied credentials. Once everything is looking good, you can click on add button to add this source. In RDA Studio, whenever you make changes to these credentials, either adding, deleting, or updating, you need to restart the Jupyter Notebook kernel. You can do so by hitting this action button in this panel. Okay, you need to restart, and then it reinitializes, and then you will be able to see the applied changes. How to view the source bots? So in the Studio action menus, select the add new pipeline. So it opens a small page, and then you have a show helper button here. Since I already clicked, it is showing as hide helper. So by default, it shows the show helper button. And then you have a small, bots text field here. It's a free form text. You just type in, it shows, if there are any matching bots as you type in here. I just typing in Linux-inventory. It is showing all the available bots associated to the source that I've added. Linux-inventory is the source I've added, and it is showing all the corresponding bots here. And this is the source name that you're typing here. So once you look at these bots, you wanted to look at the configuration of the bot, right? What parameters it supports, and what are the default settings, what are the mandatory parameters. You select a bot and you click the arrow mark button here. When you click on this, it shows the supported bot parameters. You can see the parameter name here, and then you can see whether each parameter is which ones are mandatory, which ones are non-mandatory. What is the default value if there is one, and your help text which explains what this parameter is all about. Adding a pipeline. So within this action menu, add a new pipeline. You have a name. This is where you enter the name of the pipeline. You can name whichever the name you would like to apply. Depends on what type of data automation you're going to perform out of this pipeline. And then you have the text box. This is where you add the pipeline content here. While you're typing, let's say you made a mistake, you wanted to revert. So it's not like a notepad. So it doesn't have too many options. So here, the simple options are provided. Let's say if you wanted to undo or redo. So these are the only two options available. If you make a mistake, you want to revert back. And then you wanted to expand this text box, right? The pipeline content text box. So here you have the zoom button. You can expand this. So this will expand this box to give you more real estate. Once you type the pipeline, you can click on the format. Once you hit the format, it will just reformat the pipeline in a proper structured way. So once the pipeline content is ready, you can click on the verify. Verify basically validates the syntax errors if there are any typos or any syntax problems. It will not have an ability to verify the logic in some complex cases, but it verifies the syntax. Obviously, before executing this pipeline, you click on this verify and make sure all of the bot configuration is appropriate. And then you can save it. You can have a save button, and then you can execute it to execute the pipeline. So one of the important aspects of the pipeline development is, as you build the pipeline, you need to know how the data is being flowing through these different bots, how the data is being transformed. If there are any errors, what is that error, what it means, and how you can identify and how you can address it. So it is called as data inspection. It is primarily for debugging purposes, and it is primarily available in RDA Studio. So the first thing is, when you execute, it will just show you that the traces of the pipeline execution. It shows the bot name. The green represents is good, and it flows through all the subsequent bots. And at each step, it captures the data frame state. So once it is completed, it shows green. If there is error, it will show in the red state. We'll go through in the lab exercise. So once the pipeline is completed, you have under the inspect tab here. Each row represents a data frame after the data transformation from the previous bot. Output means it is the final output. And then when you select that one of the row, in the bottom, it shows the data frame details, basically. You have the plot type, different data options. We'll look at it. Basically, looking at the raw data, or if you want to look at the schema of the data, or if you wanted to perform inline aggregations in order to see the different counts and min max and whatnot, you can perform under using this menu. Once you have the data frame here, you have the three boxes here. One is the content fetch. It's a free form text fetch. You can type anything. If there is a match, it will filter. It will show the records. And you have the expression box here, which basically supports your CFSQL filter. When you are dealing with hundreds of columns, right? It'll become very difficult to scroll through these columns, right? That's why you have the simple column filter here. You just type in the column names with the regular expression format with a pi symbol. It just it looks for that matching columns and it filters and shows you the data. It is really, really powerful. While developing the pipeline, you'll be able to look at this and inspect the data at every step of the pod. So these are the some caveats part of the data inspection. So this data inspection feature for debugging is only available in RDA Studio. And it is available only for the last 20 bot execution within a RDA pipeline. When you have like 100-step pipeline, obviously it will not be able to capture all the 100 steps, but it will show you the last 20 steps. There is a reason behind that. So the data inspection is very limited when the RDA pipeline runs on an RDA worker. So this data inspection is available only when the pipeline is running on the RDA Studio. The reason for this limit is because the data is maintained in the memory. So the memory is used for the data inspection in RDA Studio, and it is not released until the Jupyter Notebook kernel is restarted, which means you have a pipeline and your input data set is, for example, let's say 50,000 records. Let's say part of the development, you're adding the bots and you're validating, inspecting, or you keep rerunning the bots, keep rerunning the same pipeline. So obviously in the memory, it will keep accumulating that memory by a number of times you're executing. So you just need to be wary of this memory usage. In order to clear that memory, you can restart the kernel or the container of the studio. So a quick caution here. So you need to look at this memory usage, especially if the data set or data frame size is very huge, like 100,000 or a million records with 40 or 50 or more columns. It consumes a lot of memory. So these are some of the caveats when it comes to data inspection in RDA Studio. Metadata and data variance. So so previously we were talking about under the plot type, you have different options to explore the data, not just the data, but the metadata of your input data frame or output data frame. When you select the describe, it describes of the data and it shows all of the columns that are available in that data frame. It just gives you the quick data variance check. And each column, what type of data is there, how many times they are repeated, whether they are the unique values or not. If there are any null values, what is the percentage? This provides you, to perform a quick verification of the data that came out of the RDA pipeline. If you wanted to check the schema of the data set, so there is an option, when you explore the data set, and there's a plot type called columns. When you select that, it just shows you what are the columns available, what are the data types, and what is the sample value for that particular column. If it is a text, what is the sample value? If it is a numeric, what is the sample value? For example, in this case, it determined the data type as text, but the value, sample value is 4542, right? So this way you can determine whether this data type is appropriately determined by the system. So if it is showing text means not all the values within this column is integer. There could be empty strings or some text fields as well. So RDA Studio allows you to export the data. Once you build the pipeline and test and validate, and you finally get the final output, you wanted to export this data for offline analysis or for some other purposes. There is an option called under plot type export data. When you export the data, it exports the data as a CSV file, and the CSV file is located under the download section within the RDA Studio. Once the pipelines are validated, you have a publishing option from the Studio itself into the RDAF platform. So there is an action menu called Publish a Pipeline. You can select the validated pipeline here, and you can specify the versions. The pipeline support the versioning. Whenever you make a change, obviously you need to update the version number. By default, it doesn't update. So you have to manually increment the version number. Otherwise, it will override the existing pipeline. And you can specify optionally the labels. What is the use case of this pipeline? What is the category of this pipeline? So when you click the publish button, it pushes this pipeline into the published pipeline of the RDAF platform. So how do you check on the RDAF platform? This is the path. You can log into platform and main menu, configuration, RDA administration. Under pipeline sections, you have published pipeline. So you will be able to see this published pipeline in the RDAF platform in this location. So within the Studio, additional to Notebook, we provide the terminal access as well. It provides you access to the RDAFabrix, client CLI. How do you access? So basically, you can click on the file and new, and there is a terminal option. It opens up the terminal. It gives you two options. One is the RDA terminal interface itself, using which you will be able to run one or two bots in sequence for a simple use cases. But primarily, the usefulness of this terminal is it gives you the access to the RDAFabrix using this RDAC shell. So select the option 2, and it gets into RDAC shell. So yesterday, part of the exercise, we ran RDAC pods from the CLI VM, management VM. So it provides the same CLI access in RDAC pods, for example. Since we are already in the RDAC shell, we are not giving RDAC space pods command. We are just giving the pods, which is the sub command option of the RDAC. It is giving you the output of all of the microservices registered in the RDAC platform. So so this is an example. You can type the help, which shows all the commands available under RDAC. Okay, so how these same artifacts look under or RDAF platform, what are the other artifacts are available? We'll go through this in this module. In order to access the portal, you can use the browser and type this URL with your RDAF VM IP, the platform IP. And we have created yesterday part of the lab exercise, one MSP admin user, Acme admin, so you can log in with that username. So these are the menu options. You have the under the configuration, you have the RDA administration, where it will allow you to administer and configure your pipelines, dashboards, P streams, stacks, and blueprints and whatnot. And then you have the RDA integration. So this is where we add all the source credentials in the RDAF platform. Apps administration allows you to administer and manage the AOps application. Fabrix Health will show you all the running and completed pipelines, and also it will show the health status of the workers. And you have the main administration menu, which allows you to perform the RBAC level administration, IAM integrations, icon management, white labeling, and whatnot. So pipelines in the RDAF platform, you have the draft pipelines and the published pipelines. So the draft pipeline is a pipeline which is still considered to be under development or in the validation stage. So these pipelines can be executed on RDAF platform in a standalone mode. These cannot be automated using the service blueprints. Draft pipelines cannot be scheduled and can only be executed manually, as I was just explaining. And then these pipelines, once validated, the draft pipelines can be published. A pipeline that is published, which is considered to be validated and it is ready for production use. So draft pipelines must be transitioned to the published state to enable automation through service blueprints, including either scheduling or running them as a service. How do you manage? You go to configuration, administration, and pipelines. You have the draft pipelines or published pipelines. How do you add a draft pipeline? So when you go to that pipeline section under draft pipelines, you add, there's an action button called add with text, and this is a pop-up you would get. So you enter the pipeline name and you enter the version. So when you specify the version 01, the system, what it does is it automatically translates into the current timestamp, like in a date format, and it uses that as a version. You can specify the folder for organizing this pipeline. Category and use case you can type. These are optional fields, but just for understanding and organizing, you can specify what is the category and what is the use case for this pipeline. And you have to choose the worker site while saving the pipeline. So depends on the bots that you're using, and when you save it, what the platform does is it pushes this configuration real time to that worker and requests the worker to validate and comes back whether the pipeline is in good shape or if it has any errors. So you can save this pipeline, and if it is a validated pipeline, you can select this checkbox and you can publish at the same time. So these are some of the actions available for the pipeline management. So when you execute the pipeline, so it opens up a pop-up form before you can hit the run button. So it has two options. By default, inspect pipeline traces option is disabled. For debugging purposes, you can enable it so that you can see certain level of data as the data is being processed through different bots. Once the pipeline is executed, you can click on action menu. We have the view traces option to look at the pipeline status. It just shows you the sequence of this bot execution with the timestamp, your data frame changes here, and finally it shows you whether it's successful or failed. RDA workers and site groups. We briefly talked about this topic. RDA worker services are stateless and run both within the RDAF platform or at the edge locations. So these RDA worker services are grouped using the worker group environment variable. It's also referred as a site. For example, if the RDA worker group labeled as RDA-Lambda. So that means at that location, all the workers that are tagged with this name, they will work as a group, as an aggregated compute source, which will ready to accept the pipeline executions. So this grouping is primarily used for load distribution and also for high availability. So while executing the RDA pipeline, worker site group, it needs to be selected, which will make sure that the pipeline is executed on the right RDA workers. If you have the workers distributed in multiple locations, obviously the pipeline, the bots that you use could be applicable on a particular site, could not be applicable, depends on the access that workers has to the endpoints. So that's why it is very important to select the worker group. And then we have the service blueprints, which automates these RDA pipelines that were built and tested and validated. The service blueprint allows you to group these pipelines, and it can be deployed as a service, and these can be run as a scheduled pipelines or a service pipelines or action pipelines. What is a scheduled pipeline? So RDA pipeline that is configured as a schedule within a service blueprint, it will be executed at a specified schedule time. It is useful for any data collection periodically, not real time, such as asset discovery and inventory. Service pipeline, in contrast to schedule, these pipelines will be run continuously as in service, like a service mode, making them ideal for processing stream data such as logs, events, and metrics in real time. Service pipelines are monitored and administered by the scheduler service. In case the service pipeline fails because of the worker goes down, restarts, the scheduler will automatically reschedule that service either on the same worker or on the other worker automatically. And then we have the action pipelines. Let's say if you wanted to publish these pipelines as action buttons within the service blueprints, you can configure the pipelines as action pipelines. So one quick note, a service blueprint can include scheduled service or action pipelines either individually or they can be combined together within a single service blueprint itself. Okay, how to manage these service blueprints? Let's say this is an example for scheduled pipeline. So service blueprints are configured in a YAML format configuration style. So this is the configuration, and you can go to configuration, RDA administration, and service blueprints. You can click on add button, and then you can configure this YAML format. So these are the fields. Like you need to specify the name, alphanumerical name, and ID. It should be unique identifier across the RDA platform. Again, it can be alphanumerical ID. You can specify the version, and you can say whether when you save this service blueprint, whether you wanted to enable it upfront or you want to disable it, and before you can enable it. You can specify the type of it, type of the service blueprint, either schedule or service or action. And then you can specify this schedule underscore pipelines notation here, under which you have the subparameters where you specify the name of the pipeline. It has to be published pipeline. What is the label? Just to give a comment. What is the version it should pick it up. If you specify the star, means it picks the latest version of the published pipeline. The site represents the site group, and the site type you can specify the regex basically. Regex means, let's say if you have site RDA site 01, 02, 03, and even though they are different sites, but they can be grouped together. Even though they are separate sites, you can use the regular expression format as well while defining the site, or you can give the absolute name. Since these are scheduled pipelines, we support scheduling through cron expression. So if you're aware of the cron expression in Linux world, it supports exactly same format here. And then we have the service pipelines. It is a similar configuration, most of the parameters, but here you have the service underscore pipelines notation here. So some of the fields are common to schedule pipelines, like name, label, version, site, and site type. But unlike schedule, we have the number of instances. Since it is a service pipeline, the same pipeline can be run as a one service or multiple services. Depends on how you build the pipeline for streaming the data and processing them. So in this example, number of instances selected as 2. And the minimum instance are 2 and maximum instance 2, which means when you submit this and save this service blueprint, this particular pipeline will be spawned 2 instances. They will be running in parallel. So when you click on the saved pipeline, this is the window you would get. You have 3 tabs. Depends on the type of the pipeline. So if it is a combination of service and schedule, you will see the combination of them. So you have a status tab here. Status will show you whether the service blueprint is enabled or disabled. If it has any auditing errors, it will show you the audit report here. So this is where you can check, if you are facing any problems with your service blueprint. It will validate whether the pipeline is valid, whether the configured workers are available, and the configured, the source integrations, the source names are, the credentials are found in the vault, and all the artifacts that are you use like data sets and streams, all the dependencies, what is configured within the pipeline, it will show you the dependent artifacts here. If you wanted to enable or disable, there is an option here. You can click on disable to disable it. You can click on enable to re-enable the service blueprint. And we have the service map here. Basically, it's a visual representation of how the bots interact within the RDA pipeline for data automation. So in this example, we have a Linux inventory pipeline. It is taking the data from the source, which is the Linux. This is the data source, is a source credential bot. And then it is taking the data input from a data set. Basically, it is taking the data input and passing that input to this source, and finally the output is returned to the destination stream. And then you can click on the schedule or service tab here. You can see if it is schedule pipeline, it will show you what is the configured schedule pipeline, and what is the cron expression for the schedule. And if it is already being scheduled and executed, you can see the job status here. And then if it is let's say it is scheduled for every 24 hours, but if you wanted to execute on demand, without waiting for the schedule, you have an option, run now option as well. And then we have the dataset management. Datasets can be added, imported, or these can be automatically generated through pipelines. If you wanted to upload a CSV file as a dataset, you can go to RDA administration, datasets, and under you have the datasets. You can add the dataset by clicking this action button, and then you can specify the dataset name. So when you specify the dataset name, make sure that there are no special characters except the underscore. And you can click on the action here, which allows you to select the CSV file. You can upload a CSV file. So especially when you're uploading a CSV file, make sure there are no hidden special characters. I mean, this issue can happen, when you copy paste the data from external sources into a CSV file and try to save it. So sometimes visually it is not available, but that is something you need to be aware of. System tries to address some of them automatically, but some special characters which are hidden, Unicode or data formats, it might cause issues. So once the data set is added, you have these action buttons. When you click on the manage data, you can visualize the data. When you manage the data, when you get this pop-up form, you can apply the filter to filter the data. If you wanted to add an inline row, you can click on add row. If you wanted to delete a row, you have option here under this action button. You can delete a row. Once you make the changes, you can commit the changes and you can save the data set. Or if you wanted to replace the entire data by importing a new CSV file, you can click on the import. And P-stream management, you can go to configuration, RD administration. You can go to persistent stream, and you can add the P-stream here. So obviously, as we discussed yesterday, P-streams are used to persist the data for asset inventory, alerts, incident metrics, events, logs, for analytics and reporting. So you can specify the P-stream name, and then you have the attribute section, which takes the settings in JSON format. You can specify if it is in an updated mode, you can specify the unique keys. If it is a append mode, you can you can skip these options. And then some of the P-stream settings like index number of shards, replicas, and refresh interval, how frequently, how fast you wanted to index the data for data reporting. And you can click the save button to add saving the P-stream. So once the P-stream is saved and the data is ingested, you can click on the P-stream to visualize the data here. So there is a filter bar here. You can click this filter bar to filter the data based on the fields available within this P-stream. And you also have the time filter. If it is a time series data and if it has some timestamp fields, you can use this time filter to search the data by the time filter. You have this saved icon here. As you use the filters, some of these commonly used filters are saved here. Recently used saved filters. Also, it allows you to save your favorite filters. You can click here. You can see the recently used used filters, and also you can use the saved filters to instead of typing again, you can just use these saved filters. And you can click on the stats page here. It will show you the metadata of the P stream. It will quickly show you what is the earliest record, latest record within the P stream. It will show you the number of records the P stream has, what is the size of the P stream, and what is the backend supporting index in the OpenSearch service for this particular P stream. When you click on the metadata, it will show the schema of the P stream. It will show you all the data types. So one of the important data point, very important as far as P stream is concerned, is since we are using OpenSearch, it is a schemaless data database, and so when you ingest the data into the P stream, it automatically determines the data type of each field based on the first value of the record. So if its first value is like text, it will automatically determine as a text field. The first record has a date timestamp, it will determine as a date timestamp. If it has a string, numerical value, it will determine it as a long or a float. So in some cases, that's why it is important that in some cases, numerical value may be incorrectly identified as a text field, which can lead to issues when configuring the widgets in the dashboard. For critical field types, it is recommended that you need to explicitly set field type in P stream settings while creating the P stream itself. So as an automation platform, RDAF provides very rich RESTful API interface through Northbound. It is a Swagger style open API format, which is the industry standard format. So how you can access these APIs? It is a self-explanatory, Swagger style, documented an API interface. You can access the RDAF platform like this URL, your IP, platform IP /swagger/docs. It opens this document, and you can click on this authorize. You can enter your login credentials. It will authorize. You can try the different APIs inline within this page itself. Yeah, with that, it concludes our introduction to RDA Studio fundamentals, RDA fundamentals, and how to navigate through Studio and our platform UI, and how you can access the REST API. So we have the lab exercise now. Any questions? We can pause here 5 or 10 minutes, and we are open for the questions if you have, before we jump into the lab exercise. So I assume that yesterday you're able to access the lab, and you're able to install the platform, and the Studio is up and running. And there were a few issues at the end. So one of the instance IP address with 154, there was a issue while resetting the admin password. So we identified that the platform, the portal, one of the portal front-end service is not deployed properly. So we looked at it, and we just redeployed it. After that, the issue has been addressed. So that functionality is back to functional. Also, we have seen issues with while configuring the RDA Studio in the Docker Compose YAML files. There was some formatting copy-paste errors, which our team able to assist, and those issues also addressed. So assuming that all of your lab instances are installed with the platform and Studio is ready, because that is a prerequisite for this lab exercise. Okay, let me. Okay, I'm sharing the screen again. So hope you got the updated lab guide. So there was some of the sections are updated for today's session. Please make sure that you have downloaded the latest lab guide today. Okay, so with this, let's go to day 2 section. And so you can open up the browser to access the RDA Studio, and you can open the Jupyter Notebook. So either you can click here or you can go to File, New, and Notebook here. So I'm going to click this one. So as I mentioned yesterday, so you can check the status of this Jupyter Notebook initialization in the bottom. It's showing as connecting, and wait until it is showing as idle. Okay, it is idle now. It is good. I'm going to type Studio, and I can click on the play button here. So we got the RDA Studio application. Okay, so the first exercise is to add all of the data sources. Yeah, please refer our lab environment guide. Additional to the lab exercise, there is a additional document. So where you have the credentials to all of the different sources like VROX, Jabix, vCenter, Linux, Windows, Kubernetes cluster, and email SMTP server. So as part of that first step, let's add all of those sources. So you drop down this menu, there is an option called Manage Bot Sources. Okay, and you have the Add, Edit, Delete failed sources. So I'm going to click on Add. The first exercise is adding the VMware vCenter credentials. So drop down, I'm going to go to the bottom, look for VMware vCenter v2. V2 is the up-to-date version, so let's use that. Give the name for this integration. Let's say, as for the lab exercise, should be vCenter lab, and give the IP address. Please refer your lab environment document. Username. And the password. Increase the timeout to 60 seconds and click on Check Connectivity. Okay, so it validated the integration with that vCenter, which means it is able to communicate to the vCenter. There is no timeout, and it is able to authenticate with the given credentials. Now click on Add button. So after adding this source, typically to apply this, to use these bots, we need to restart the kernel. But since we have additional steps of adding other sources, let's add all of the sources together, and then finally we'll restart the kernel to apply all of the source bots. Okay, vCenter is added. Now I'm going to go to add the Linux host credentials. Go to this drop down again and look for Linux-inventory. You can highlight and you can press the key, let's L, it goes to that particular one. Linux inventory here, and I'm going to name this as Linux. And enter the IP address. So the IP for the Linux integration, the IP that we specify is mainly to just quickly validate the credentials, not necessarily for the actual discovery. The reason is the bots takes the IP range or the list of IPs as the input. So the IP address that we specify is ignored, right? This is primarily to validate a target Linux machine is connected with the given credentials. Give the username and the password. Okay, so we are not going to use the private key here. So we added the credentials. Scroll down and you can see the port. This is a default port. You can keep it as a default. Click on check connectivity. Okay, so I'm able to add, sorry, I'm able to validate the connectivity and authenticate. I'm going to click on add button. Since I've already added, that's why it is showing, it's saying like this bot, so the sources already exist. But in your case, you should be able to add. Let's go to the next source, Windows. Hope you are able to follow and able to add these sources and validate the check connectivity. Okay, drop down here, search for Windows, press W key, Windows inventory. So for Windows inventory, we have the two types of integration. One is the SSH-based integration, which means like Windows servers are running the SSH or open SSH service or a native SSH service. So the default one without SSH name uses the WinRM. So in this lab exercise, we are going to use the WinRM protocol. So type the name as Windows, all lowercase, and the IP address. Go to the lab document. Give the username administrator. And the password. And leave these default settings. You don't need to modify in this lab exercise. Click on check connectivity. And I'm able to connect to this Windows using WinRM protocol, able to authenticate. Click on add. I'm able to add this Windows bot, Windows source. So the Windows is added. Now let's move to the next source. We are going to add the Kubernetes cluster now. Drop down, press K, and select the Kubernetes-inventory. Kubernetes integration supports both SSH-based integration or API-based integration. In this lab exercise, we are going to use API-based integration. So name, Kubernetes, leave this as a default. Login method, select this API, which is default, leave it. And the hostname IP address, we need to give the Kubernetes cluster master IP address. And 73. And since it is an API-based authentication, we are not going to use username, password, or password key. So these fields are applicable for only SSH. Scroll down, and you have the port section. Since it's the API, the default port is 6443. So update the port here. Select the protocol as HTTPS, which is the default. Leave that as a default. And then copy paste the API token. Please refer your lab environment document for the API token. When you make sure there are no extra spaces when you copy paste, it's a long JWT token. Okay, I pasted here. Click on check connectivity. Okay, I'm able to connect to the Kubernetes cluster through API, able to authenticate the API token. It's all good. Click on add. So since I've already added previously, that's why it is complaining that this source is already added. In your case, you should see the green status. Okay, so the Kubernetes source is added. Let's go to the other source. So we're going to add the Jabix now. Okay, go here, drop down, type Z, click on Jabix. Name, leave the default as a Jabix name itself. Host name, the IP address of the Jabix. Go to the your lab document. Okay, this is the IP address and username and password. Leave the protocol as a HTTP because it's a lab instance. Go to the document. Even port also 80. URL prefix. If you have any front-end load balancer, typically you would have this Jabix URL prefix for authentication. So in this case, we do not have any. So remove the URL prefix. Leave the timeout as is and click on check connectivity. Okay, so I'm able to connect and authenticate. Click on add. So I'm able to add the Jabix source. Now let's move on to the next source, which is VMware VROPS. Okay, drop down, click on V. Have VROPS here. The name, leave this default name as is. Let's update the host name, the IP address. Go back to the document. Username. So you have the two credentials in the document. So you need to use the discovery and metrics credentials for this exercise. Username is read only. And you have the password. Click on check connectivity and click on add. Okay, I'm able to add VROPS. VROPS is done. Now let's move to the next section. Now we are going to add the email server to send the email notifications part of this lab exercise. Okay, drop down, have E. There's a source called email_sender. Okay, so leave the name as email. So we have created one specific Google account just for this lab exercise. So you can go to the lab environment document, scroll down, there are SMTP settings. So copy the sender email address. Email username is same. Copy the password from the document. And type the SMTP server. And leave the security as TLS, port as 587. You can click on check connectivity. It should be able to integrate with the Gmail using these credentials, and you should be able to add this source. I'm going to click on add. Since I've already added, it is showing us it's already been added, but you should be able to add successfully. So with this, I'll give a quick pause. I want to make sure you guys are able to follow these steps and able to add all of the sources. Ram, can we quickly check among all the participants? Okay, I'm going to pause here. So if you have any questions while adding these sources, you're stuck, any issues, please post your questions. So one question is, do we need to manually add each server same way? The answer is no. As I was explaining while adding the Linux source, we are just adding the username and password of the target machines. So typically in an enterprise for asset discovery use cases, you will have a service account with some restrictions from the firewalls and everything. While adding the credentials, obviously we wanted to verify those credentials against one or two machines to make sure that the credentials are valid. So once the credentials are added, you can mass discover the Linux or Windows host by inputting the list of IP addresses or subnet range to the bot. So the answer is obviously that adding the source is only for the credentials as far as the Linux or Windows is concerned. So in the same context, you have some other sources like vCenter, for example. vCenter bot is the integration is per vCenter. Obviously, unlike Linux or Windows, when it comes to vCenter, if you have 10 vCenters, so you need to add the 10 vCenters credentials separately, even though they are same. So once there's a question, just going through Q&A. So once we publish the pipeline, how do you get the pipeline back to draft? So there is no direct option, but what you can do is you can just edit the published pipeline, and you want to make a change or you don't want to make a change, but just click on save. When you do that without updating the without updating the version and without selecting the publish option, even though you are under the published pipeline management, when you click on save button, by default it goes back to draft, which means a copy will go back to draft. It doesn't delete the pipeline which is already in the published state. So hope that answers in a little more detail. So one question is, devices will not discover automatically. So answer is obviously for any system, automation system, the data need to be inputted. Let it be credentials or the list of IP ranges, and that is what we are doing. Once it is done, once it is established, once it is configured, the system will keep discovering and periodically based on the configuration, which does automatically without any manual intervention. And it keeps track of out of that how many devices are discovered, how many devices are not discovered. All of those status will be captured. Yes. So is there an option to onboard these devices bulk? Yes. Option is yes. You can capture all of these devices in a specific format. We'll cover that part of tomorrow's exercise. But list of IPs by type and some tag values for each asset, and you can import that CSV and you can feed that input to the pipeline. So to import those devices and discovered in bulk. Okay, I think so we can give a pause here, Ram. Maybe we can take a lunch break and come back.
Yeah, sure.
45 minutes.
Yeah. And we can
See my screen? Can you see my screen?
I can see.
Okay. Hope everyone was able to follow the document and able to add all of the data sources. If anyone is having any problems while adding these data sources, please post us. Our team will look into it and help you to sort it out. So as we added all of these data sources, as I was talking about, we need to restart your Jupyter Notebook kernel. That step was captured in the document. Okay, so I'm going to hit that restart the kernel button. Okay, so when while it is restarting, you can check the status here. It goes into the restarting mode and then followed by unknown, and eventually it will come back to idle state. So you have to wait until it comes back to idle state. Okay, let's give it a moment. Okay, it is come back to idle. Now go back to this cell, Studio, open close parenthesis, and click on this play button to restart the RDA Studio application. Okay, so the first exercise, we are going to create a simple vCenter integrated pipeline, and we'll follow through these pipelines step by step, part of this exercise. Okay, the first step is we need to create a pipeline. So this is the RDA Studio application. You can drop down this application menu and you can click on add a new pipeline. So I'm going to add a new pipeline. So the name is going to be VMware vCenter VMs inventory. So I'm going to type the name. And as per the lab guide, I'm going to copy paste that pipeline content. Okay, so I copied the pipeline content, and I'm going to click on format to format the pipeline, and I'm going to verify. Click on verify. It shows here all the bots are showing status as okay, which is good. Okay, now let's quickly go through this pipeline. So we started with a new control block, new block, and using the vCenter Lab VMs bot. This bot is going to query the vCenter, the source that we added, part of the previous exercise, and it is going to collect all the VMs data. Once the VMs data is collected, it is going to dedupe the data by instance VMs instance underscore UUID, and finally going to save the collected data, deduped data into this a persistent data set. So before going into executing it, I just wanted to quickly go to this show helper and navigate through how you can search for these available bots and look at the help text. Click on show helper, and you have the bot section here. Let me type vCenter lab is the source name I've added. So you can see that under vCenter, these are all the bots available. We have vCenter summary, vCenter alarms, VMs, hosts, switches, data stores, networks, adapters, polling the events, clusters, resource pools, and whatnot. So in this exercise, we are using the VM. So let me click this and click on help text.
So when you click on this button, it gives you the details about that bot. It gives the help text about the bot, like it collects the VM inventory detail, and it has these parameter values. If you want to skip on the error, by default is no. If there is a failure part of the integration, it will fail the bot and it will fail the pipeline. If you don't want that, you can make it yes, so that it will skip the failure and continue with the rest of the steps. Retry count, if you wanted to retry if there is a failure, these are the parameters. If you wanted to query specific a VM, you can specify the VM details, basically the virtual machine name. So these are the optional parameters. So we are not going to use any of these parameters because we are going to leave the defaults and execute the pipeline. You can click on hide helper to hide the help text. Okay, I'm going to click on the execute button now. Okay, so as we all are trying to collect the data from vCenter, there are going to be many API queries and sessions. It may be a little slow, but it should not take too much of time at the same time. So it is executed, and you can see the pipeline status. It is completed successfully, and you can see in the final output it has 83 columns and 39 rows. We'll look at the data, and you can see the bot execution status. So it executed the vCenter lab. A source collected the VM's inventory, and it executed this TM dedupe, and finally saved the data into a persistent data set. Now let's look at the the data by clicking on this inspect. When I click on the inspect, you can see all of the executed step. As I mentioned as a caveat, it will show the last 20 bot executions. Since we have very few lines in the pipeline, so we are able to see from the start to the end. So this is the starting bot. So obviously, it doesn't have any input because it is a source bot. And we have added the credentials in the source itself. And when I click on the next bot, right? So from this bot to the dedupe bot, you can see the data frame in the bottom. It queried and collected the data and fed this inventory data as an input to the dedupe bot. And you can see the duration. It took like 7.4 seconds from the first bot to the second bot. And in the bottom, you have the all the collected data. So by default, it shows the complete output of the your incoming data frame. When you drop down this, you have other option to navigate through and look at the schema and other data. For example, I want to look at all the available columns, look at the schema. Select the columns, and you can see the schema of this data frame. It shows what are the columns available, and based on their data and how the system automatically detected the type of the column, whether it's text or numeric or a date. And for each column, it is giving you the sample value. Okay. And then you can drop down and you can look at describe. Describes helps you to look at the data variance for each column. You have the search option and you can filter the columns, but I'm not going to select anything. I want to look at all of the columns. So click on apply. So it is working against the entire data set, and it is showing the column by column, and it's saying for this column the count and what is the non-null value, and which means if it is 100%, which means this field is populated for every record. So you can see the top values distributed by percentage and number of unique records, unique values within each column. let's go back to the data here and click on get data. So we have the 83 columns here. Now I wanted to quickly look at the all the data points. So one way is you can slowly navigate through like scrolling through all of these columns and the data. The other way is you can for a particular record you're interested. Let's say you can select the row and if you scroll down, it shows in the vertical form. For that row, it shows you all of the columns and their corresponding value. Okay. So now I have so many columns, 83 columns. Now I quickly wanted to check the VM VM name column and some ID column, MAC address, and power state, right? Either I can go through each column or I can filter these columns from here. I can say name, pipe, which means or, let's say IP, or it's a regular expression in supported format, which means if this string matches with any column, irrespective of its position, it will be able to filter. MAC, state, ID. So I wanted to filter the columns which has these strings like name or IP or MAC or state or ID. Apply. Now you can see the number of columns came down to 13. So now you can clearly see, I can see the name of the virtual machine, the state of the virtual machine, the source IP address, which is the vCenter IP address, and the storage name, which is the data store name. It is a VM ID, it's a NIC IP addresses, MAC addresses. So this is where you can quickly filter the columns within the data inspector. Let's pick this one and take this name. This is the VM name. I'll remove this column. So let's go back to the full dataset view. And I'm going to try this content, which means it's like a free form text. I don't need to type, let's say, some string here. When I apply, it is basically applying the filter. You can see that the number of records came down to 25. It searches across all of the fields inside the data frame, which matches this particular string. Okay, that is one way to filter. And then we have this expression, the CFXQL expression here. Let's take, let's say name. We can say name. So virtual machine name contains this VM name. We can remove this like this. Okay, so this way also it is very specific, looking for that particular field, and then you're applying the CFXQL filter. We can also try some other filter. Let's say guest contains Ubuntu, and I want to look at name and guest column. Okay, so when I apply the filter, you can see that it is able to filter all of the guest operating systems which are Ubuntu, and filtering the columns with the name or the guest. So whichever the column matches, it will get you that information. So if I say guest does not contain Ubuntu, okay, now you can see that it is giving you all the VMs information that are non-Ubuntu. Microsoft Windows, CentOS, other Linux, anything that is not Ubuntu, right? So this is how you can, as the data is flowing through, getting transmitted and transformed, you can inspect the data and you can visualize the data for any troubleshooting or debugging before you can validate and certify the pipeline. Okay. Get data. Now let's get goes back to the full form, 183 rows and 83 columns. Now this is the input to the dedupe. What we are doing is in the pipeline, by instance VM instance UUID, we wanted to dedupe. So this output is collecting the data from the vCenter, and each VM has the either one NIC or two NICs, or it might have one or more disks. So as it is flattening the data, what it is doing is, if there is a VM has 3 disks, it is showing the 3 records for that VM because it has 3 disks, and if it has 2 NICs, it will show 5 records. So it has duplicate records. So for a certain type of data you wanted to dedupe and filter the data, you can apply this dedupe, and we are using here the VM's instance UUID. Now that input is passed to this dedupe and it went into the save. Now what you're looking at is, you can see the number of records came down from 183 to 39. So it deduplicated that the data by applying that instance UUID, and it is giving you the unique VMs based on the UUID. Okay, and finally it is saved to the dataset, and the output is the final output. Okay, so that is the exercise. Okay, so we looked at this data frames. We went through this content filters, expression filters using CFXQL. We went through how you can filter the columns here. And then we went through how you can look at the metadata of the data frame through columns and describe. You can also do the group by, let's say, if you want to look at the number of guest operating systems. So group by, let's look at the guest. Okay, you can do the aggregations here. I want to aggregate by this guest column, and I wanted to use this count describe. And now you can quickly see number of guest OS VMs we have distributed between CentOS, Windows 2012, 2016, other Linux, RHEL, and Ubuntu. Okay, so this is a quick way of visualizing and inspecting the data. Hope you all able to follow. So let's move on to the next one. Okay, so now we are looking at how to export this data. Select the final output and drop down here. There is an export data option. Click on that. When you click on that, it exports that data as a CSV. Click on that and it shows you the output in CSV format. Okay, and it exports as well. The exported data will be available under downloads. For that, you can click on this folder icon on the left side. And you have this downloads folder here. Click on it. and then you can see that file is exported here. You can right click and you can rename. Let's say vCenter VMs dedupe inventory. And then right click and you can download this file. Okay, this file is downloaded here. I do not have Excel in the system, so it is just open in the text file. Okay, so that concludes the exercise of how to add a simple pipeline and add few bots, like collecting the data from a vCenter source, and how we can transform the data by applying the dedupe bot and saving to a persistent data set. And then we went through the how to do the data inspection at the each bot layer. And we went through data exploration in content expression columns. So, and we're able to export the data as well. That concludes that. And now we can move to the RDA pipeline exercise 1. So this exercise is basically create a pipeline called Linux network config data transformation, in which it queries, integrates with the Linux host OS, and it queries the network configuration from one or more Linux hosts. And you can explore the data with the inspect, and we can do the data transformation flow in step by step. Okay, so with this, let's make sure we save this file, the pipeline. So obviously, after execution, validation, make sure you click on save button to make sure the pipeline is saved. Okay. Now we need to part of the new exercise. We wanted to add a new pipeline. For that, what you need to do is you can just refresh the menu here, go to about RDA, and then come back to add a new pipeline. Okay, so we got the new pipeline now. Part of this exercise, I'm going to type this pipeline name as described in the lab exercise. And going to copy paste the first few lines of bots, which we are going to start with. Click on format and click on save. Let's make sure we are saving this pipeline. So in this case, there was one question when we add the Linux data source, right? So we are using that Linux bot, and these bots are sync bots, which means they take the input from the previous bots. So let's go to the show helper. Let's look at this Linux bot here. Linux network config. This is the bot we are using. Click on help text. And so you can see these are the parameters this bot supports. There's only one mandatory parameter, column name. What is this column name? It's the column name which contains the IP addresses. So, so in this case, we manually entered the IP address. So in the real world scenario, this can be coming from a data set, and the data set is already uploaded with the CSV file, which will have either 100,000 or multiples of thousands of IP addresses, and which will feed as the input to this particular bot to collect the data. And then what we have here, so there is a concurrent discovery parameter as well. So obviously, when you're discovering these Linux endpoints, when you have thousands of them, you can define the concurrency to improve the collection times. By default is 10. You can increase it to 20, 30, 100. Depends on the environment size. Okay, and then we have some connection timeouts, CLI timeouts, so which we are going to leave them as a default. What we are saying here is we are starting off with an empty data frame, which means it doesn't have any data at all. And then we are adding a record with a column called IP_address with a comma separated IP addresses. 172, 173, 174. There are 3 Linux host OS IP addresses. Now we are calling this Linux bot network config, and we are defining this parameter, which is column name, which is mandatory. And we are saying what is the column from the input data set, which is this one, the column which has the IP addresses, which is in this case IP_address. Okay, this is the input, and we are passing to this bot. Okay, now click on execute. Okay, it is executed and successfully completed. Click on inspect. When you click on inspect, you can see the data flow here. The first one is the empty bot, which means it doesn't have any information. That's why you saw the 0 rows and 0 columns here. Okay, but if you go to the Linux bot, what is the input? The input is the add row, the record that we have added. It has a single column called IP_address, which has the comma separated IP address values, and passed as an input to this bot. This bot now connects to these Linux 3 hosts and executes certain commands and collects the data and flatten the data in a simple tabular format and gives you the output. Click on output, and this is where you see the output. Okay, you can see the collection status, collection timestamp in milliseconds, and then you have the interface capabilities, interface names, your IPv4 IP addresses, IPv6 if there are any, link status, upstate, and this data is coming from which Linux host IP address, which is represented in the source_IP. The states shows whether the interface is up or down, right? So these are some of the data that Linux host is providing, part of the network configuration collection. Okay, and when we check the output, so one of the exercises is look for the columns that has special characters, right? So when you click on one of the record, let's take this one, the second record, and scroll down. You can see most of the columns are clear, clean in the sense a single word, or you have the underscore, which is acceptable special character, but you have some of these columns which has the special characters as slash, right? I have 1, 2, 3, 4, 5. So I want to normalize them. I wanted to normalize them using the fixed columns bot. So let's use that fixed columns. So I'm going to use that bot here. One way is you can come here and under this show helper, let's say fix columns. Okay, this is the bot available. You can click on help text button here. It will show you the supported parameters. Optionally, you can include specific columns, but we are not going to use the specific. We're going to just run with the defaults. Copy that. -- arrow. Click on format and execute. So the pipeline is executed, and you can click on inspect, and you can see here the network bot output is inputted into the fixed column bot. And the fixed column bot applied the transformation for the columns, and finally it generated the output. So this is the final output. Now let's pick the one of the row and let's check the columns status here. Okay, now you can see here there is no forward slash. The special character is gone. It automatically replaces the special character with underscore. So this is how it normalizes the columns using the fixed columns bot. Okay, so that is the one level of transformation. And then what we are going to do is we are going to filter the data using the interface name. And since some of these Linux hosts running virtual interfaces like Docker interfaces, loopback, some Calico interface, tunnels, we want to exclude all of them and wanted to pick the actual Ethernet interface, right? So for that, we are going to use the filter bot. So I'm going to copy this line from the lab document. Click on format. Okay, so what we are doing here is we are using the DM filter bot, where we are using CFXQL filter here. We are saying if underscore name does not contain any of these values, if they either loopback or Docker, Calico, or tunnel. And I wanted to include both the interfaces, their status, the state is up or down. I want to include both of them. So before using this, obviously you can look at the inspect and look at the corresponding column name, right? So you can look at this is the column name which has the interface name. That is how you can find this information and use it part of your filter bot. Okay, now let's execute this. Okay, it's executed and completed. Let's go to the inspect. Click on the filter. Now you can see that you have the input data frame has 38 rows. After applying the filters, it brought down to only 5. Okay, when you click on the 5, you have the filtered, the data set. You can see that under interface if underscore name field, you don't see any of the loopback interfaces, Docker or Calico or tunnel interfaces. Okay, and you can look at the state. You can look at the state here, and it is picking both up and down interfaces. If you wanted to filter only up interface, you can just modify this filter. It should be able to get you the data with the interfaces. The status is up. Okay. So that is the exercise. And then extending the pipeline now we have so many 25 columns, right? We wanted to selectively cherry pick the columns, the important ones. For that, we are going to use the select columns bot. Okay, I'm going to copy the line from the lab document. Okay, format. So here we are using the DM select columns bot, where we are saying out of this input data set coming from filter bot, include only these column names. It supports this regular expression based. So it's saying source underscore IP or if underscore name, state, inet, and I'm explicitly saying with this regular expression notation, I want to exactly match the word link underscore ether. So there are some other attributes which will have this word. We are not interested. So that's why I use this format. And collection attributes and reason if there is any failure reason. Okay. We've added this bot, execute. Okay, it's completed. Click on inspect now. Okay, now you can see that from the filter, the data inputted into select columns where you have filtered 5 rows and 25 columns. After applying the select columns, the final output, you have only 13 columns, right? You have 5 rows and only 13 columns. If you scroll down here and click on it, and you can see the match, the selected columns only filtered and you have the final output. Okay, and so extending further, I wanted to rename some of these fields so that it is normalized so that I understand as a user much better way. So for that, what we are going to do is we are going to use the rename columns bot. I'm going to copy paste from the lab document. Okay, so I'm using the rename columns bot. Okay, so I have the raw columns, but I wanted to rename them. Okay, so you have the it's like a key value pair. On the left hand side, it is the new column name, and the right hand side is the existing column name. Okay, I wanted to rename source underscore IP as a host underscore OS IP. I wanted to change the interface IF underscore name as NIC underscore name, state as NIC underscore status, link underscore ether as a MAC address, INET as a IPv4 address, INET6 as IPv6, and this one as a broadcast. Okay, so either you can put all of this in a single line, or you can enter for the readability purpose. You can specify these parameters in the new lines formats as well. And then after renaming, I wanted to set this the columns in a particular order. Okay, for that, we can use the DM filter bot. Okay, format. Now what I'm doing is I'm not, for example, if you see here after the filter bot, you have star. I mean, this is the CFXQL position from syntax point of view. I'm putting star means I'm interested in to get all the records. I don't want to filter any records. Okay, out of that, I wanted to get, this is the result format, which I explained during the slides. I want to get the columns. These are the columns. Okay, whatever the columns I specify in a comma separated, it maintains the exact order. So I wanted to, follow this order like host IP, nickname, status, MAC address, and rest of these attributes. Okay, now I'm going to execute and go to inspect. Okay, the first thing is after the select columns, the data is inputted into rename columns. Okay, you've got 13 columns and 5 rows. You can see here we have INET, INET6. This is before renaming them. When I click on the filter bot, which means it passes through the rename columns, now you can see some of these fields are renamed to however we configure. The if name renamed to NIC underscore name, and INET is renamed to IPv4 address, IPv6 address, and link ether is renamed as MAC underscore address. Source IP is renamed as host OS IP. Okay, so this is how you can inspect and make sure it is working as expected. And now we applied the filter to set the order for the columns in the final output. And also we explicitly specified which columns you wanted to include part of the output. Okay, so click on the final output. Now you can see the exact order it maintained, right? Starts with the host OS IP, nickname, status, MAC address, v4, v6, followed by all of these columns or fields that we specified in the filter bot. Okay, let's click on save button to save it. So this is the one exercise just to show how we can transform the data the way we want. And the next step is, we wanted to transform the actual data by using the map bot. This is one of the powerful bot when it comes to the data transformation. So we wanted to make the MAC address value all of the characters into uppercase. Okay, so I'm going to use this bot. Okay, so MAC address is the column or field. So MAC address is here in this one, and this is the map bot, and we are saying which attribute you want to work on. Selected MAC underscore address, and what is the function we would like to apply. Right, upper is the function. We'll look at the help text in a minute to see what are the available functions for the map bot. And now, and what is the other step we have? So this is the step. Let's execute this. Okay, go to inspect and look at the final output. And now you can see the MAC address. All the MAC address became all the uppercase. If you look at the previous output, you can see. Okay, I think so. The original data is all uppercase. So let's change it a little bit to see the change. Let's make it lower. Okay. Just to see the data transformation here, let's execute. Inspect. Now look at the final output. Yeah, now you can see that all of the uppercase letters became lowercase. Okay. So there are so many functions are available: lower, upper, strip, split, slice. Let's look at the what are all the functions that it supports, right? Go back to this show helper here and do DM functions. DM functions and click on this. So it lists all the available functions. So it is not a consumable bot, but it just gives you the functions that system supports, which can be used part of the DM map bot. Okay. So these are the functions. You have the checksum. You can derive a checksum from the value. You can concatenate the value. Datetime function. If you wanted to evaluate, days between two timestamps, fixed value, and yeah, you can go through all of these functions. You can generate an MD5. You can find and replace. If you have the UUID in Little Endian and Big Endian, you can reverse the format. Seconds between two timestamp, slicing, splitting, stripping. You can generate some synthetic values, random values. You can get the current time. You can convert the timestamps, right? So you have so many functions that are available out of the box, using which you will be able to perform a lot of these data transformations. Okay, now we are going to go to the next step. We are going to derive a new column, new field, based on the existing data using the DM eval. Okay, and the first step is, let's copy this DM eval from the document. Okay, so what we are doing is we are evaluating. It supports the Pythonic expression. So this is the new column. I wanted to derive this column based on the certain conditional value of the existing field. Looks like there's a typo. So in the lab document, I think there is no space. I think there's a typo. Please correct this here when you're using eval. It might fail. So what we are saying is if there is an IPv6 address exists and if it is non-empty, which means the IPv6 address is configured. For that, I'm deriving a label called configured for this column. If not, I'm going to say it is not configured. Okay, when you execute this, inspect, click on the output, and now you can see IPv6 address status is the new column is derived, and it is this value is derived based on the condition. If the IPv6 address is there for the interface, it is saying it is configured. If it is not there, it is empty because it's saying not configured, right? So that's how you can use the eval to derive the new attribute values based on the condition. You can use the simple condition. You can have a complex if else condition as well. Okay, and then we are going to convert that collection timestamps. As we have seen, the collection timestamp is in milliseconds, right? So when you look at the timestamp, as a user, until unless you use some converter, you will not be able to find what this date timestamp is. This date timestamp is in UTC. So we are going to use the DM map bot, and and we are going to use the timestamp to date time string function. It is available here. So if you scroll down here, this is the function, right? So you can copy that. And we are saying what is the attribute this bot needs to work on, which is the collection underscore timestamp, and specify this function for the conversion. And the source unit, what is the input, whether it's in seconds or milliseconds or nanoseconds. This is the unit is milliseconds. Execute. Completed. Click on inspect and click on output. And now you can see the collection timestamp is transformed into ISO datetime string format, which is a user-friendly time format, which you can look at it and understand at what time this data has been collected and processed. Okay, and finally, we are going to save this as a data set, a persistent data set. On format, click on save to make sure and execute. So in this case, we are not using temporary data set, it's a persistent data set. So executed, inspect, it is completed. Okay, this concludes the first lab exercise for the RDA pipeline. Hope you are able to follow this and able to make progress. Any questions, please let us know. Rob, can you ask a question, please?
%87% of the people said they're following it. Funny.
Okay, that's good. Okay. Okay, so there was one question. I think it is a bit older question. While doing the column filters in the inspect, when you specify the name, why it is showing, storage name, other things. So as I was explaining, this columns filter is a regular expression based. which means when I say name, it looks for all the columns that has the name value. It doesn't matter whether it's a partial value or the full value. It looks for that, and whichever matches partially or full, it gets the column. Since the storage name has the name, that's why it was showing that. If you wanted to make it an absolute match, then obviously you can use something like this, as I am highlighting the screen. You can say this up arrow and name and ends with a dollar, which means you're telling the regular expression that it needs to be absolute match, and it doesn't entertain any partial match. So in that case, you will get only the name field. Okay. So I think we can continue now. Okay, now exercise 2. So we are going to keep extending this pipeline to make it more interesting. So what we are going to do is we are going to extend this pipeline, adding a new control block and collecting the system level inventory, which collects the host OS version, kernel, CPU, make, model, host name, and all of that. And then use that data performing some if-else conditions based on the IPv6 configuration and some enrichment and configuring the formatting templates and sending an email. Okay, the first thing is we are going to add a new control block. So I'm going to start with this few bots just wanted to explain. So this is a new block, and as I was explaining, so there's a previous block here. Let me zoom in a little bit. So the data starts from here and it ends here, right? So when I start the new block, this data doesn't flow here automatically, right? So I started this new block and I'm starting with empty data frame, and this Linux bot expects this IP address as a input. So I'm defining this, and I'm passing this IP address input as a parameter to feed in this IP addresses. And then I'm using fixed column just in case if the output columns has any special characters to takes care of all of that, and execute. Okay, it is able to execute it, and this is the final output, and it is able to get the system level inventory, which gives the information about CPU, memory, host name, the type of the VM, bare metal, virtual, all of this. There are plenty of columns there. There are 60 columns. So within that, we are going to transform the data, right? In the sense, I wanted to normalize all of these columns into user-friendly format. So for that, I'm going to use the DM filter. Okay, so there are ton of columns are there. So in the DM filter, you can not only filter the data and set the order, but within the filter itself, you can rename the columns, right? So for example, I have the host name. So I want to keep it as is, but I wanted to rename the source IP as a host OS IP, right? So you can specify this is the original column. I wanted to rename as host OS IP. Operating underscore system, I wanted to rename as a host OS underscore version. So you can keep doing that for all of the columns. Okay. And what we are going to do is we are going to convert the collection timestamp into the ISO format. Where this bot, and then I wanted to lower the BIOS UUID. Okay. Format. taking the host bios UUID. I'm just lowering it for the data transformation. And then we are going to do a couple of eval bots to derive new attributes. So I wanted to derive whether the host machine type is a virtual or bare metal, right? So I'm going to eval with the if else condition Pythonic expression. So I want to derive this host machine type. I wanted to say, it is a VM if there is a VMware string in the host machine model, or a word in the host machine model, or VMware in the host Hyper-V vendor, or Microsoft in the Hyper-V vendor, or Xen. So I have multiple conditions here. Else, it is a bare metal. If none of them matches, which means this covers pretty much all the virtualization vendors in the market. If it doesn't match any of that means it is a bare metal. Okay, I'm deriving this eval. So let's execute. Okay, inspect. Okay, the first thing is let's go to this filter and map here. This is where we renamed all of the columns, right? So here you can see all of the renamed columns, and they're coming in a particular order in a nice and user-friendly manner, which you can clearly understand what each field is meant for. And then we are doing some lower operation, and then we are eval, and finally output. So let's look at the host machine type, right? Let's type here, type column. You can see here the new attribute is derived. It is saying these all of them are VMs because you can search for serial. You can see some of these attributes which we are using as a condition has the VMware string. Okay, that's how it is able to determine these machines are VM or a bare metal. And then there is another eval bot. I wanted to derive the vendor, whether it is who is the machine provider, right? Whether it is a Microsoft or VMware or Red Hat KVM. So you have this eval bot. Okay, host machine vendor. I'm deriving whether it's a VMware vSphere, if it is a VMware string in the host machine vendor and some of these attributes. Microsoft, if it is a Hyper-V, and then if it is bare metal, obviously you can have HP or Cisco, Huawei. Or otherwise, if it can't determine, it can say it's unknown, right? Let's execute this. Let's look at the final output, and let's search for vendor. And you can see it derived the host machine vendor VMware _ vSphere. Okay. And now further, we are going to go and compute the memory. So the memory coming in as a kilobytes, we want to convert into gigabytes. Okay. So you can look at the column here. Let's say mem. You can see the memory in the KB. We are going to derive the new attribute host _ memory GB. So what we are doing here is we are using eval. Again, it's a Pythonic expression. This is the actual field on which we are going to compute this value, and we are doing the arithmetic operation. So if the value comes in any decimals, we want it to round off with a 0 decimal, right? That's what we are. So we are converting first into megabytes and then the gigabytes. And we wanted to do this only if this attribute has some value. If it is empty, we wanted to skip it. Skip it by keeping the original value. Could be empty value, right? So let's execute this. Click on inspect and click on the output, final output, and search for the columns mem. Now it should show both KB and GB. Now you can see here you have the original column _ KB, and you have the newly computed column which is in GB. Okay. Okay, let's add the another bot to type, which basically sets the data types for some of these numeric columns. Click on format. So here we are using this bot to type. We are saying I wanted to set for these columns like host memory GB, host CPUs, cores per socket, CPU sockets, threads per core, which has all of the numerical values. I wanted to explicitly set the data type as integer. Okay, we are setting that, we are using that bot. And then finally, we are saving this data set. So in this case, we are going to use the temporary data set. Instead of saving as a persistent, we are going to use the temp notation to tell that it is a temporary data set. Okay, save name temp dash, which means it is not persisting into the disk, but it is saving in memory while executing the pipeline. Okay, let's save the pipeline. Okay, so we are able to execute this and we are able to derive the host machine vendor. We are able to compute the memory in GB. And we are able to set the data types. Okay, and we saved as a temporary data set. Okay, let's save it. Now it's completed. Okay, now move further. Now we have the two data sources. One is the we collected the network configuration from these Linux hosts, and then we also collected the system level data points as well. Now what we are going to do is we are going to create a new control block and recall this network configuration and enrich that with this some of these OS level settings. So when you look at the network inventory, so it has only the source IP and the IP address interface name and all of that, but it doesn't have any information about that host belongs, a host is running on which operating system, what is its host name, and some of the very important identity information. So we are going to create a new block and going to recall that this data set. Okay, so it's a new block, and then I'm using the recall bot. So recall bot is the bot which allows you to recall in any data set within a pipeline. So if it is a persistent data set, obviously it can be reloading the data from your backend storage service. So in this case, we are recalling the network config inventory, which we have saved in this step. Okay. Now we wanted to enrich this data with the system level inventory, which we saved as a temporary data set, right? So we are getting data from one source, which is from Linux OS network config inventory. We're enriching with another source, right, which is a temporary data set in this case. So for that, we are using the enrich bot with the dictionary. So we are saying dict, what is the dictionary, which is this temporary data set? What is the source column? So this is the source column from the input data set. So from this one, I wanted to use the host OS IP. And what is the dictionary column for the lookup? So here I'm using the same attribute, because in both of the data sets, this attribute is same. If both of them matches, I wanted to enrich this input data set with the host name, host OS version, machine type, machine vendor, and machine model. Okay, with that, let me execute now. Okay, click on the inspect. Now let's start from the recall. So this is the control block, and we have recalled, and let's see what is the input here. Input to the enrich. So you can see here, there is a host name, there is no OS version, and any of those attributes. Now we are using enrich bot and looking up into another temporary data set and enriching with additional columns. So now you can see the change, right? The 12 columns became 17 columns, which means there are some matching records. It is able to enrich. Click on the output. Now you can see the output here. Click here, look at all of the attributes. Now you can see this data set is enriched with host name and the host OS version, what is the machine type, machine vendor, and machine model. Okay, this is how you can enrich the data between the two different sources. Okay, we looked at the enriched data, and then what we are going to do is, before we continue further on this exercise, we are going to open two terminals to try the streaming bots part of this pipeline. Click on File, New, Terminal. So it is going to open one terminal. So I'm going to open another one. File, New, Terminal. I have two terminals now. Going back to terminal one. So what it is saying is, so we need to choose the option two to get into RDAC shell access. Okay, so we are into RDAC shell access, which integrates with our RDAF platform. So here you can run the help to see all of the available commands which are available. So here we are going to use the read stream. There is a read stream command. We are saying read stream, and this is the name, and Linux IPv6 configured stream, and there is another one in the another terminal 2. So basically what we are trying to do here is we wanted to listen into these streams. In the pipeline, we are going to do the if condition and identify the interfaces which are configured with IPv6 versus the interfaces which are not configured. So we wanted to see the output in these streams when the data is written to the streams here. So I have two streams here. We are just listening in. So which is one is unconfigured stream for the IPv6, other one is configured stream here. Okay. So as it is a streaming command, it is subscribing to the backend NAT service, and it is waiting for the data. So you can see the message here. It is subscribed to this this particular subject. Okay, now come here and so here we are going to extend this pipeline. Let's start with the one step, one if condition here to the format. So here what we are doing is I wanted to apply this if condition. Look at the IPv6 address status. If this field is set as configured, I wanted to write to configured stream. Right? This is the if condition. Within this output, I have 5 rows, out of which 3 of them are. We can look at the this field status. 3 of them are configured, 2 of them are not configured. So when I write this stream using this if condition only, you should see the three entries in this stream here. Okay. Click execute. Okay, it's completed. Now let's go to the terminal here. Okay. Now you can see that the data is written to this stream, and you can see the we can see that the data can be read here. There are 3 records coming from 73, 74, and 72, and for which the interface, the IPv6 is configured. But if you see here, there is no there's no data because we haven't written, but we are going to add that. But the point is, it is filtering the data based on the condition and routing the data into this particular stream. Now we are going to extend this and going to add another condition. Now we are going to configure the unconfigured IPv6 interfaces format. So here, what we are saying is, if the condition IPv6 address status is not configured, write to this unconfigured stream. Okay. Now execute again. Okay. Now if I look at the terminal 2, I can see the 2 records. Right. For these 2 interfaces, the NIC status is down and there is no IPv6 is configured. Okay. So that's how you can use the streaming bots for to write into, and also you can use the if conditions based on certain values. You can take different actions. So in this sample example, we are writing to the stream, but you can send a notification. You can do something else as well. Okay, let's save this pipeline. Save the changes. Okay, we completed this exercise. And now let's extend this pipeline to make it a little more interesting. Let's create a formatting template, right? So we talked about you can derive this formatting template to format the output data, and especially when you're sending a notification, either email or opening a ticket in a very structured, friendly format. So we can create that. So for that, what we're going to do is we are going to create open another notebook. Click on File, New Notebook. Click on Select. Wait until the status becomes idle here. Meanwhile, let me type the studio function. Okay, and from the drop-down menu, select the formatting templates edit. I'm going to create one formatting template. The formatting template name is I've already created, but let me recreate again. Yeah, copy this content from the lab document. Please make sure you copy the entire content because it's a HTML format. Make sure there are no syntax errors. So this is the formatting template. It's HTML body. I have defined the variables here, the labels, sorry, like host name, OS version, machine type, and everything. And these are the actual the field names, which will be substituted with the actual values in the runtime. So this notation is a Ginger 2 format. Maybe you can search in the web and find out. Ginger 2 is very, very powerful, especially in applying data formatting in this the way we are doing it here. This is a very simple example, but you can do a lot of complex formattings as well. So we are going to format this based on these fields and save it in a part of the formatting template. Okay, now it is saved. Let me go back to this pipeline. Let's go to the steps. So in this lab example, what we are going to do is, so we use the if condition here, and then we are identifying the interfaces that are configured with IPv6 and the ones which are not configured. We are going to extend this. Additional to writing to the stream, we wanted to send an email notification. Okay, so add few lines here. The first thing is we wanted to apply the this formatting template. So for that, we are going to use this apply template by row bot. and the template name is the one that we just created here. So this is the template name. Sorry. And then we wanted to capture this formatted data into output column as email underscore body. Email underscore body is a new attribute, and which is going to store the final output of the formatted data, which can be used in the further bots. And then so we are going to use the email bot, email send bot. Let's look at the help text here. Email and send bulk message help text. Okay, so this is a sync bot. It expects these are the parameters. It expects the recipient as a column, which means it is expecting this parameter is passed as input from the input data frame. And what is the subject column, which has the subject information? What is the message column? And what is the message type? In this case, it's a HTML we are going to use. So we have to define these attributes within the data frame before we can call this bot, right? So let's prepare these inputs here. So first thing is I'm going to use the eval email underscore recipient. So obviously you can specify your email address here. So you have the double quotes and your single quotes. Please make sure you maintain that. So I'm going to use my email address. Okay. So one column is defined, and the next one is email subject. Okay, in the email subject, I'm defining a custom message using the Pythonic expression, using the formatting notation here. So I'm saying like critical alert. I wanted to replace this with the actual host name and with the nick and actual nickname, nick underscore name from the input data set. And it's saying is not configured with IPv6 address. Okay, so email underscore subject is defined. And then I'm going to create a new column with the message type, MIME type. So I'm going to use the add missing columns. So the reason I'm using different bots for the same purpose, just to demonstrate that certain operations can be done in a number of ways. You have different bots which can do same things, right? So add missing columns. So I'm defining what columns I wanted to add. In this case, I wanted to add only one column, which is the message underscore MIME type. So this is the one. This is the one we are looking at. And the value is HTML. And then finally, I'm going to use the email bot. Okay. So here, what is the recipient column? Email recipient that we derived here. What is the subject column? Email underscore subject we derived here. What is the message column? Message column is an email body that we derived part of the formatting template bot as the email underscore body. What is the message MIME type column, which we derived here? Message MIME type, the value is HTML. Okay, so all the prerequisites are satisfied. We configured the all of the input parameters. And then we are going to save this output as a temporary data set just to see the results, just in case if there is a failure. Okay, and then click on the format. Okay, click on save. And now let's execute. Okay, it is completed. I can go to the inspect. I can see send mail bulk, the command is, sorry, the bot is executed. I can see there are 2 records. This is the final output. Now, if I click on this output, the single record, you can see the email body, right? So you can see. So this is the email body, the email that you receive in this format. This is all because of the formatting template using that HTML body, right? So you have these labels, which is defined part of the formatting template, but the values are replaced during the runtime, right? So I have received the 2 emails to my mailbox. Let me share this. Yeah, you can see this one. I received the email, and this is a subject. You can see here some of these variables are substituted with the actual name and the nickname, and it's saying like not configured with IPv6 address. Okay. Okay, let's go back to the lab. Okay, so that concludes the this particular exercise. So there is a question for any discovery pipeline: is it mandatory to set the type of the data? Most cases it is not necessary, but when it comes to visualization, and when you which we are going to cover tomorrow. Let's say if you wanted to do some charts like counter charts, and you wanted to compute, you want to do some aggregation. To perform that, the data types come into the play. Otherwise, for the text fields, for most of the scenarios, you don't get into any issues. Other than these type of very data type specific situations, we need to make sure those data types are properly configured. So I just want to give a quick pause here, and please ask us the questions if you have any. Hope you're able to follow and apply the same within your instance. Ram, can you post a quick question just to see if everyone is able to follow?
Yeah, sure.
Okay. Okay, we'll continue. So what we are going to do is we'll make a slight modification to this bot just to see how we can, as we are writing the data to a stream, and how we can listen the stream data from another pipeline, right? So for that, what we're going to do is we are going to just remove these lines that we just added to send an email. Okay, and let's save it. Format. Save it. Okay, that is the first step. And then we are going to open the notebook here, another notebook, and we are going to add a new pipeline. Add a new pipeline, and then the pipeline name is email notification for IPv6 non-compliant interfaces. Can't save. And then we are going to use this bot. Okay, so for testing, we'll start with this one. We'll perform few operations just to demonstrate some of the nuances of using the streaming bots in the studio. Okay, so we created with simple line using where we are using read stream bot, right? And we are specifying this is the stream name, and as you can see in the first pipeline, this is the stream unconfigured IPv6 interfaces we are writing to a stream, right? So we are using the same stream name, and we need to specify this is the consumer group because we are subscribing to the stream. Okay, and then let's click on the execute. Okay. Okay, now this is a streaming bot. That's why it is in the running state, right? So now go here and then execute this pipeline. When you execute this, inspect, it has written 2 records into the right stream. Now you come to this studio. Now you can see that it went through 1 iteration or 2 iterations, right? Click on inspect. We can see there are 2 records came in. Okay, so that's how you can write to a stream where you have another pipeline running in parallel, looking for the data, and then as the data comes in, it will process. It does the way the pipeline is configured. So that way you can daisy chain these pipelines one after another for exchanging the data between 2 different pipelines. Okay, so now let's extend this. Let's do the similar exercise. Filter the data and send an email. Right. So within this read stream, I'm as the when the data comes in, I wanted to filter the data by applying the if condition. I wanted to send email only if it has found any interfaces that are not configured with IPv6. Otherwise, I don't want to send an email notification. Okay, click on format and click on save. Since this is a streaming pipeline, in order to kill this, we have to restart the kernel. Okay, restart the kernel. Okay, the studio came back to idle state. Over here, reopen this studio menu. Go to edit pipeline because we already saved the pipeline. Go to edit, select. This is the pipeline, and then let's execute now. Okay, now it is in the running mode with additional bots looking for this condition. And if it matches, it will send an email notification. Now go back to this original pipeline and execute again. Okay, come back here. Now you can see, it went through all of these bots as the data is being streamed in using the read stream, right? Look at the inspect, and now you can see the email has been already sent. Okay, you can see the pipeline, and that concludes this exercise. Yeah, my bad. I didn't update this. We need to make sure we update this email address. Okay, it went through that loop again, and you should see an email notification now. Oh, my bad. I think we updated the here. It doesn't apply because it's a streaming bot. So we have to restart the kernel and try again. Okay, restart the kernel. So which kills the service pipeline. Sorry, I mean like this streaming pipeline. Line. Okay, let's execute this. It's running, and execute this parent pipeline. Okay, you can see here. Okay, emails being sent. Let's check. Yeah, the email recipient is there. Now I received the 2 emails. Okay. Okay, so this concludes this lab exercise. So Ram, let's take a quick 5-10 minute break and we can resume.
Yeah, we'll take a break. It's almost 14:45. So let us reconvey at 14:55.
Okay. Okay. So hope all of you able to finish. Okay, let's continue. So now we are going into RDA pipeline exercise 4, talking about data loops. Okay, so we need to create a pipeline to collect the data from Linux host inventory, system info, network config, disks, and disk usage bots using a loop bot. That is exercise. So let's create a new pipeline. Okay, let's open a new notebook. new notebook here, click select. Okay, let's open the Studio application. Click on add a new pipeline. Enter the name as a Linux inventory with a data loop. Click on save, and we're going to add the pipeline content here. Okay. So here, what we are doing is we are creating a data set. Starting with the empty data set and manually adding these records like IP address column, Linux source name, and inventory bot. So there are two things we're going to see how it works. And one is how we can pass the source name as a dollar variable, and then at the same time you can pass the inventory bot, the system info, disks, and network config and disk usage. Okay, so let's try to understand this first. We created this data set with these columns and saved as a temp data set. Now let's look at these bots, right? Where we wanted to collect these bots from the Linux inventory. So go to show helper and click on Linux column. Now you can see here system info. This should match the actual bot name. System-info, and then we have the disks, and then we have the network-config, and then we have the disk-usage. Where is that? Yeah, disk-usage. So these are the bot names, and the source name is Linux, and we captured this here. And these are the input IPs. We are creating a temporary data set. So let's execute and verify. Go inspect and output, and now you can see I have a column inventory underscore bot with the system info, disks, network config, and disk usage, and we have the IP address and then the Linux source name. Now let's create a data loop block here. Okay, copy the content from the lab guide format. Okay, so now we are using this data loop control block. What we are saying is use this data set, the temporary data set here. And within this data set, I wanted to use these columns like IP address, source name, and inventory bot in a loop. So when we execute this, it takes these 4 entries, right? It takes each record and then it substitutes these dollar variables here. What we are doing is we are creating empty data set and adding a 1 record, IP underscore address, which we are going to pass as input to this Linux bot. So if you see this Linux bot notation, right? Actually, it should be source name column, the bot name, right? Here we are deriving this during runtime using the dollar variables. So these values are coming from your data loop data set and the data loop columns. So this IP address, it is this particular IP address coming from here, and this Linux source name is coming from here, and this inventory bot is coming from here. So since we have 4 records, it executes in a loop 4 times, and then it creates this persistent data set. So even the persistent data set name, we are using this dollar variable, right? Since it is a loop and this values is going to be replaced during runtime, and obviously it's not going to overwrite because each bot name is unique, right? You have system info, disks, network config, and disk usage. Okay, save the pipeline and execute it. Okay, so it executed. If you go to the inspect, you can see clearly, and it is running one bot at a time, right? And click on this. You can see these values are automatically replaced, right? And then the disk usage, and finally saving the output into this data set. Now with that, this pipeline is completed. Let's verify that these data sets are created. For that, what we can do is, let's open another Studio application. Go bottom here, go to Studio, open. Yeah, you can open multiple Studio application within the same Jupyter as well. And go to, from the menu, explore datasets. And then you can see here, right? You can see a Linux host OS disk usage inventory. So this value is automatically populated by the dollar variable during runtime. So you can see here disk usage inventory, disks inventory, network config inventory, and the system info inventory. Okay, select this, get data. We have all of the collected data. This is the file system data, mount points, and their disk usage. Can do the disks inventory, get data, and you can see all the raw disk data, their state and their size, the disk vendor, if it has any, the file system type, and then the network config. Okay, this is the network config data, and then finally the system info. Okay, so this is how you can use the data loops within the pipeline. There is use case, it requires to be use the data in a loop, and if you want to use a dollar variable, so this is one of the approach you can use. Okay, so with that concludes this exercise, and let's go to exercise 5. Okay, so this exercise is basically creating a pipeline with the vCenter bot to collect the vCenter manager virtual infrastructure details that it manages, and then process it, and then write the data, the process data, into a P stream. Okay. So with that, we are going to move into RDA Fabric platform UI because we need to create the persistent stream. So for that, let's log into the platform UI here, and log in as a Acme admin. Before, I'm sorry. Okay, to create the persistent stream, go to the main menu, configuration, RDA administration, and then the persistent stream here, persistent streams, and click on add. Click on add, give the P stream name. So the P stream name should be vCenter summary stream, and then the attributes. So this is going to be a inventory type of data. So we are going to set the P stream as a update mode, not in append mode, right? For that, we need to define the unique keys. So it's a JSON configuration. For the unique keys, we are specifying unique _ ID. So it is an array. Either you can specify single field or a comma separated in an array format, multiple fields as well. We are going to click on save. Okay, and click on the top tab here and reload. So it is being created. And look at this running status, collection status. Sometimes it may take up to 15 to 30 seconds. Make sure it is in the running state, after creating the speech stream. Okay, so that first step is done, and then we are going to create another piece stream. This one we are going to use the little later exercise, but as we are here in this page, we are going to create another one, the Kubernetes event stream. So this is another piece stream to demonstrate and practice how to create a piece stream in the append mode for the time series type of data like events, alerts, and metrics. So for time series type of data, obviously, they generate a lot of data. What we are going to do is we don't need to set the unique keys because it's not update mode. So it is an append mode. So we're going to set this retention days for the data purging. We're going to set, because it's a lab exercise, we're going to set it to 1, just 1 day. And click on save. Reload, and yeah, this persistent stream is created with the retention days as 1. So which means like any data which is older than this 1 days, the data, the records will be automatically deleted from the piece stream. So how it identifies every record that it ingests into the piece stream, it uses it derives a timestamp field at the ingestion time, and it is going to use that the record's timestamp to check its age, and if it's older than 1 day, it automatically deletes the record. So we created the 2 persistent stream as part of this exercise. Okay, now we go back to RDA Studio. And come here. Since we already completed this, let's refresh this. And we are going to create a new pipeline. Add a new pipeline. And name the pipeline as vCenter summary inventory into a piece stream. Okay. Con save. And let's add the bot here. Starting bot. Con save and execute. Okay, it is completed, and we can see the output here. So it is able to get the vCenter manager level summary data. Its version, its identifier, the name, number of data stores it is managing, number of hypervisors it has, number of VMs, all of this information, capacity, storage, and whatnot. Okay. So now we wanted to format this data. So using the DM filter bot. So let's copy the content. Okay, so we are renaming all of the fields. We're keeping the vCenter address, IP address as is, full name as a vCenter full version, build as a version build, and some of these columns being renamed just to normalize and make it user friendly. So let's execute this and inspect, and you can see all of the modified fields in a particular format, nice and tidy. And then we are going to transform the collection timestamp and then derive the unique ID, right? So since it is going to be the data to which we are persisting, it is going to be in update mode. And we define in the P stream that unique underscore ID is the unique field, which is going to be used as a key to determine the record's uniqueness. What we are doing is the first is we are converting the collection timestamp into date timestamp string, which we already did this in the previous exercise. So to derive the unique ID, we are taking the combination of vCenter address and vCenter UUID, right? So vCenter UUID in this case typically the unique UUID, but we just wanted to be more cautious, especially when you are running in multi-vCenter environment. When you have so many, we just wanted to add additional uniqueness to it. So that's why we are using the combination of vCenter address and vCenter UUID. And then it is going to use this unique underscore ID combination of this using the function join. And when it joins the values, we want to separate by underscore. Okay. I mean, you can use without separator, but here in this exercise, we are using the underscore. So when you execute it, go to inspect and go to the output and look at the output here. So if you scroll down, you can see the unique ID here, right? So unique ID is derived from the vCenter address underscore the UUID of the vCenter itself. Okay. Now we have transformed the data the way we want. Now we are going to persist the data by writing into a stream. Copy this line, format, and save, and we are going to execute. Now it is going to write the data into this stream. So there is one difference. So earlier also in the previous exercise, we used this write stream bot, and then but we didn't create any P stream. That means the data is written into the stream, but it is not persisted, which means the data is maintained only in the memory. And if there is a consumer, the message will be consumed. And if there are no consumers using read stream or other application service, the data will be lost because there are no consumers. But in this case, what we are doing is when we are writing to a stream, we configure the P stream. As I explained in one of the architecture slide, the RDA collector service is responsible in consuming all of the messages for all of the streams that are configured as a P stream. So we have configured this P stream and we are going to execute this. Okay, it is completed and it is written to the stream. Now we are going to go to our RDAF portal. Go to the persistent streams. We are already in this page as we created these P streams in the previous step. We sent a summary stream. And click on it. Now you can see the data is persisted, right? And you click on this small icon here. You can quickly show, you can quickly see all of the fields, all the inventory data from the vCenter that we persisted here. So you have the unique ID and you have this, timestamp. So timestamp is derived by the collector service. And the collection underscore timestamp is the actual collection timestamp from the vCenter inventory, which was derived part of the pipeline. Okay. And since it is a update P stream, right? So if I go back here, let's take, let's execute again. When you execute again, since we are not changing the unique ID and we have only one vCenter, when you go back here and when you refresh, you shouldn't see two records, right? Because in update mode and you still see one record because it is an update mode and we are using the unique underscore ID is configured as a primary key. Okay. Now we can see the stats of this piece stream. Click on the stats. So it shows the the timestamp. Because there's only one record, it is showing this both of the timestamp same. So this is the piece stream name and the attributes. We are using unique keys because it's update mode. The save time, the status is running, and this is the actual raw index in the backend OpenSearch service. And number of documents, only one, and the size, it is consuming so many bytes for this record. Number of shots, and if there are any shots successful or failed, and status is okay. So when you click on the metadata, this is where it shows the schema of the piece stream. So as I talked about, in the piece stream, we didn't explicitly define any field mappings. The OpenSearch automatically determines based on the first value that it gets. So as you can see, the collection timestamp, it has only one record, and it is a timestamp. It automatically determined it. It set the type as a date, and the CPU capacity, memory, and all of that, it is set as double or float. And the rest of the fields are text fields, right? So most of the times it automatically determines, but if you have the some records as the values like a numerical, but some records doesn't have it, and and if it happens to be if the first record has a field which is supposed to be numerical value and empty, it might end up determining it as a text field, and the subsequent fields has a value. Even though it's numerical, it doesn't update the field type, right? So I mean, these types are determined during the first time when the index is created, when the first record is ingested. So especially these issues will not surface during the collection and ingestion. These might surface while you are visualizing the data by creating dashboards, like counter charts and some pie charts, where it requires arithmetic computations based on the field types. In that scenarios, you might see issues, but that's why it's very important to design these piece streams initial time. Otherwise, what you need to do is you need to recreate a new piece stream and export the data and ingest into the new piece stream to fix these field type issues. Okay. Okay, let's go back to this one more step in this exercise. Go back to the studio, and then we are going to query the data from the piece stream. So we're going to create a new block. Okay, we created a new block here. So we are using this query persistent stream bot. And then we are going to apply the CFSQL filter. We have only one record, but I just want to show you that how this filtering works. We sent address is so-and-so IP address, and the short version is this. With the input name, we are feeding the input as a piece stream name, which is the vCenter summary stream, and the limit is set to 0. 0 means it returns all the records that matches the filtering criteria here. Okay, create execute, go to inspect. Now you can see the output has one record, and it is able to get from the piece stream. Okay. Okay, this one, let's save it. This concludes this exercise. Yeah, with that, this concludes this exercise 5, and let's go to exercise 6. Okay, so in exercise 6, what we're going to do is we are going to use one of the bot within Kubernetes source to monitor the live events that are happening in the Kubernetes cluster. And then we are going to write to a P stream. So we have created one P stream. Yeah, the first thing what we are going to do is we are not going to write to a P stream, but we are going to write to a stream that we want to watch the events first and see what type of events we are getting. And then we are going to process the pipeline up, add some filters, and then format it and finally write it to the targeted P stream. So with that, let's create a new pipeline. Okay, let's refresh this about RDA and add new pipeline. And then I'm going to add these two bots. Okay, I'm using the Kubernetes integration. There is a bot called watch events. So it requires the input, which is the master, the KDS cluster master IP. And then as the events are coming in, we wanted to write to this stream. It's a watch event stream just to see what type of events we are getting. Before we execute, let's save this. Before we execute, let's go to the terminal, open a terminal, cancel this one. Let's update this. Read stream name, Kubernetes cluster watch event stream. Okay, enter. So this subscribes to this stream, and it'll be waiting for the any new events that are occurring on the Kubernetes cluster. Go back to this pipeline where we created this small piece of pipeline with the Kubernetes watch events bot, and going to write it to this watch event stream. Okay, click on execute. Okay, so it is getting some events, and you can go to the terminal and we can see these events are posted to this stream. Okay, it has the object kind like pod. There is ArongoDB pod on this Kubernetes cluster that we created for this lab exercise, and some start container server, they're being deployed, restarted, right? So there are so many events are happening here. Okay. So what we are going to do is we're going to restart this because it's in streaming mode. Now we know that the events data structure, what we are going to do is we wanted to filter the events only for the pod. Before that, we are going to rename some of these columns for the simplification point of view. And then we are going to cherry pick some names, right? Okay, so let's restart, edit pipeline. And Kubernetes events to P stream. Then what we are going to do is so we are going to add the filter bot. So this time we are using the safe filter, right? So in the previous exercises, we used the filter bot. So there is a slight difference between DM filter and DM safe filter, safe dash filter. So DM filter expects all of the columns that you specify as part of the get operation. It expects the input data frame or data set has those columns. Like if you say, if you specify 10 columns and one of the column doesn't exist for whatever the reason, that doesn't satisfy the filter bots requirement, and it is going to fail that the input data set doesn't have the columns that are specified as part of the get option. So in some cases, the data can be dynamic. In some records, you might get those columns, and sometimes you may not get. In certain scenarios, when the data is dynamic and you don't want the pipelines to be failed, in that case, the safe filter will come to the rescue. So what this does is, let's say if you specify 10 columns, and if one of the record doesn't have one of the column, it doesn't fail. Instead of what it does is, it adds that missing column as a empty column. It's added to the data frame, even though it doesn't exist in the input data set. And to satisfy that data requirement, and then it continues, right? So so in this case, what we are doing is we are just renaming these Kubernetes event columns as object type and object name, involved object name as object name, and involved object namespace as object namespace. Message, leave it as is, last timestamp as a event underscore timestamp. So in this case, let's use a column which doesn't exist. Let's say custom, right? Just some random column name. And then what we're going to do is we're going to create a if condition here. Let's remove this guy. And we wanted to filter the incoming events filtered by the condition object type has pod, right? We are interested in only the pod events. And then we are going to write to the P stream. So this is the P stream we have created. This is a stream which has the P stream backing. And then you can follow it by your watch stream as well. You can put together in sequence like this. So now, so when we execute this, click on save, it is going to cherry pick only these columns. And then if the event has this object type as pod, and it is going to capture only those events and writes to the P stream. Okay, I'm going to execute now. Go to this watch stream. Okay, yeah, now you can see these events are happening. There are some of the events coming from MariaDB. Some of the events are coming from ArongoDB. Right? So this is the live streaming pipeline. And then it is being filtered, formatted, and then one more thing is, if you look at the custom, right? This custom column doesn't exist in the raw input of the Kubernetes events, right? But since we added the safe filter here, it automatically appends that column in the safe way with an empty value. Okay. So now go back to the RDAF platform here. Go to the P streams. Let's look at the Kubernetes event stream. Okay, you can see that the events being ingested into the P stream, and these are the data points. Right? You have the object type as a pod, object name, what pods they are, part of which namespace, what type of the message the event is generating, and based on the P stream, you can define alert rules, and you can generate an alert if needed, right? Yeah. Okay, so with this should conclude the this particular lab exercise.